Sì. Hello. What purpose? I will join back. Hello. Hello.
Yes, sir.
Yes, sir.
Can you audible, ma'am?
Yeah, audible.
Okay, sir. Good morning to one and all.
Excuse me, sir. Sorry to interrupt.
Uh,
Sir, I'll complete the profile reading and then take over the session, sir.
Okay, ma'am. Okay, ma'am. 5 minutes, ma'am.
Good morning, one and all. I welcome
good
you all
morning.
for the 1-week faculty development program on AI for Future. So we are on the day 2 of the program. Let me quickly let you go through the day 2 schedule. So the first lecture, that is lecture 4, will be on AI and human machine interaction by Dr. R. Sundar. And next will be a lab session, which is building AI models with Python, a step-by-step guide by Dr. Vincent. And then there will be lecture 5, which is AI in data science and big data by Dr. Sita Nath. And then we'll be ending the day 2 with the lab session, which is on developing AI models for predictive analytics, which is by Dr. Vanmati. So let us start with the day 2, lecture 4. Let me introduce you all to the resource person. So he's Dr. R. Sundar, who is an associate professor at Welltech Rangarajan Dr. Sakuntala R&D Institute of Science and Technology, Chennai. He has a working experience of 15.5 years, and he has completed his BE in CSC in 2004 at Adi Parasekti Engineering College, and he has done his MTech in CSC in 2008 at SRM University, Chennai, and he has completed his PhD in CSC in 2021 at Satyabama University, Chennai. His domain of interest are data structures and algorithms, computer networks, database management systems, machine learning, introduction to IoT. He has 13 Scopus journals and 4 SCI papers, and he has attended 2 international conferences and 2 national conferences. Sir, I welcome you to the session and please take over the sessions.
Okay, madam. Thank you. Thank you, madam. Thank you. Can you audible my voice?
Yes, sir, you're audible.
Okay, madam. So, in this section, good morning to one and all, right? So, in this section, AI with the human interactions. Myself, I am Dr. R. Sundar, Associate Professor of Caltech University. Okay. So, this our topic is in this section. So, AI with the human interactions. Okay. So, what are the agenda of today's sections are we have to discuss with them. So, definition of the AI with the human intelligence and the introduction of the. Can you share with my PPT? Everyone can know that.
Sir, I'll make you the presenter, sir, so that you can share the PPT.
I shared, ma'am, already.
I didn't get any PPT, sir.
Oh, okay. Wait, ma'am, 1 minute. Hello.
Yes,
Now
sir.
it's okay. Now it's okay.
Now we can't see the PPT, sir. Until now we saw the PPT.
I shared, ma'am.
Yes, sir. Now it is visible.
Right, okay. So AI with the human interactions. So agenda of our today's section is so what is the definition of the AI with the human intelligence and the introduction of the AI acting with the human intelligence. So basic concept of AI and simulation of the human intelligence. So AI act as a like human intelligence and the human intelligence versus AI. So what are the things are we have to benefit and how they are intelligent act as a with the AI. And aspect of chat boxing is one of the best example for AI systems. So that chat boxing we have to how they are working with that. So what are the given inputs are we have to provide it, how they are processed under the overview of the functionality, what are the challenges in the medical diagnosis. So that one of the another things we have to find out with the chat box. Then next one, how they are traffic management with the AI at the human intelligence. So these are the some other agenda only we have to discuss with the today's sections. Okay, right. So first of all, what is meant by intelligent? Intelligent means mainly for how they are human can. Huh? Hello. 12 डोसे खाने का मूड में एकदम देख रहे थे मेरे घर से मेरी फैक्ट्री देखी 60 किलोमीटर दूर. Hello. So if you have any other interrupter means there are so many difficulties that they have to handle with the sections. So please kindly we have to mute your section, right? Okay. Huh? So please kindly help with the they have to take with the sections properly. Right. So then only I have to discuss with the full concepts of the entire things. Okay. So how they are handled with the AI, then how they are acting as a human intelligence. Okay, right? Before you start with the what is meant by intelligent? Intelligent means similar to the how the humans are being think about the very effectively. That is a decision making, how they are problem solving with the effective way, how they are understanding the concept, how they are creating, how they are judgment, and everything we have to think about the human being. So that is called the intelligence. That intelligence can be act as a with AI. Okay. So AI with the human intelligence, the collaboration of intelligence between the artificial with the human conjunctive ability to solving with the problems, enhancing and decision making and improving to the overall system with the efficiency. Okay. So what are the process we have to done with the human intelligence system? The human creativity and the understanding and the judgment, this all the things are can be done with the AI. Okay. So based on the data processing and the automation of the capabilities. So that is called the interaction between the combination of AI with the human intelligence, right? Okay. So actually, what about the intelligence? How they are human can think about the intelligent way, then how they are acting as a AI with the human intelligence in the they have to providing with the some other various applications are there, right? Okay. So here see that some other applications are I have to provided. So healthcare monitoring system, traffic management system, and the customer supported. These are the some other way of first of all how they are thinking about the intelligent way. Then how humans are can be think about that intelligent way to act as a AI, right? Okay. So AI diagnosis to disease. So what are the diseases are can be affected? The doctor valid or treat with there. So under traffic management, they have to conjecture with the they are affected with the way the AI can be detected with that. And the human to managing the emergency, the customer support the chat box to the query. That is a main important things are we have to chat box, right? Okay. So that is one of the AI. To agent to resolve into the some other cases. So various cases are there. So user wants to entering into the what are the different way of thinking about the knowledges that to query they have to providing with the that results. Okay. So that is a main part of the AI with the human intelligence. Intelligent way to thinking about the human to act as a AI, artificial intelligence, right? Okay. So learning the concept, so based on to understanding to the what are the queries and how they are previous data of the processing, then we have to display into the that values are to resolve into the all the queries, right? So that is another one thing. Next introduction, AI act as a intelligent human intelligence systems. So human intelligence systems, AI act as a human intelligence systems. AI can be systems are connected with the mimic. So mainly concept of mimics and the simulate and replicated with the human conjunctive functions. So including with the what are the various way of thinking about the reasoning and the learning the concept and the problem solving perception and the decision makings. So based on these concepts, we have to think about the human intelligent way to act as a AI, right? So these systems are can be performed with the how they are human intelligent to understanding the languages and the recognition of the images to interacting with the world of the human like a manners, right? Okay. So various languages are can be used with the in the AI systems are to providing with the act as a intelligent advanced techniques in the machine learning under the neural network and the natural languages processing. So what are the things we have to providing the task or data we have to given that the data and make the decision of the pattern to predefined of the instructions. So already predefined the instruction. So based on that instructions are we have to given to providing to the specific solutions and the rules are can be solving to that, right? Okay. Right. So these are the second way introduction. So what is mean by first of all definition of the AI in human intelligence. Various applications are can be applied to the human intelligence, okay, in AI and AI act as a human intelligence. So various additional advanced techniques are can be applicable in the machine learning under the neural network and the natural language processing to based on the some make the decision to learn from the data and to make the decision of the patterns and rather than the predefined of the instructions. Okay, right. So third one, artificial intelligence with the simulation of the intelligent way, right? The concept of the artificial intelligence, the simulation of the human, think about the machine. There are three different kind of way to given the example. One is a thinking, another one is called the learning, and another third one is called the simulation of the human intelligence. Okay. So thinkings are how they are think about the decision making, how they are think about the problem solving. Okay. So that is called the human, how they are intelligent way of to thinking. That act as a intelligent artificial intelligence. And the learning, how they are machine learning and the deep learning and the knowledges are can be represented to occurring the knowledges. Okay. And the simulating the human intelligence highlights the reasoning to understanding and the natural processing. These are the some other key areas are we have to understanding simulated of the human intelligence. So everyone they have to make with the some of the three important concepts of the AI with the human intelligence. So first think one. So how they are thinking with that. So based on the decision making under the problem solving. Right. Okay. So who can be decision? So decisions are can be taken with the AI. It is similar to the chat box. They have to think about AI is a act as a they have to given the input, user can given the input and providing the outputs. Okay. So chatbot is one of the best way to given the AI artificial intelligence. That algorithms are like using just playing the games. So they decided to optimal moving with the given the strategies. So various way of strategies there. Which one is the best way we have to move from playing the chess? So that is called the decision making. And we have to problem solving with that. So it can be provided with the so A-star algorithms, some other algorithms are used with the navigation of the to robots to solving with the some other navigation of the problems. Okay. So that is called the think about how they are decision thinking the decision and how they are problem solving. Okay. So first of all, decision making to think with the some other human being. Okay, right? And it also act as a AI, right? Similar to act as a AI and how they are solving to the problems in AI, right? So next one is a learning. So data can be learned with that. So various way we have to learning with that. So based on the previous concepts, so previous things. Okay, right? So that is called the machine learning and the deep learning and the knowledge representation. So these are the some other learning concepts that we have to use to from the to machine learning means we have to some other classification and the regression techniques are we have to predefine. But the data can be we have to regress that we have to providing to the some other given the data is predictor or not predictive. So based on that things are right. Another one is called the deep learning. So automated vehicles are deep neural network to recognize specific traffics are predefined systems. So in that way, we have to decide that it is the object based. We have to thinking about. So knowledge representation is representation and the so medical knowledge to assist with the various diseases are we have to find out how they are various diseases can be affected. Okay, right? To find out with the learning the concept in previous things given the input. So if the diseases are not, we have to based on the given the data and the simulating with the human intelligence, reasoning, understanding, and the natural language processing. So reasoning means with the legal AI to platform analysis of the cases to providing insight with the predicting with the outcomes. To understanding that is a chat box to conversion with the AI and the generating with the human likes and the text response. And the natural language processing, some other Alexa and the Siri. This process can be responded to the what are the things we have to given the input that the commands are we have to directly apply to the chatbot. Then immediately we have to providing the result. Okay. So this is the main block diagram of the artificial intelligence. Okay. So artificial intelligence, they have to think about the thinking and the decision making and the problem solving. So these are the some other things are we have to solving it the problems and the thinking it there and how they are decision making. Okay, so these things are one side we have to think about. Then another way how the simulations of human intelligence to understanding and the reasoning under the natural languages of the processing. So these things are we have to done with the artificial intelligence and simulating the human intelligence, right? Okay. So AI with the simulation of the human intelligence, understanding and reasoning. AI think about their decision making and the problem solving techniques. Okay. So everyone. So what are the things are we have to given the input? They have to think under the decision making to problem solving similar to the simulation of the human intelligence, right? Okay. In AI part. That is a chat box. What are the inputs are can be given based on the previous data? What are the decision making? How they are problem solving previously? So given the data, we have to predict with that. Then how they are human can understanding and the reasoning the concept that they can be provided to decision making and the problem solving techniques are there. Hello. Right. So AI can act as a like a human intelligence. So various way we have to domaining it there. AI can act as a human intelligence. So healthcare, customer support under the autonomous vehicle under the finance systems. So mainly healthcare. So medical diagnosis systems, how they are predicting to the doctors particular symptoms are there or not. We have to treat it as a immediately we have to take the decisions and we have to predicting to that then what are the necessary steps are we have to take into the based on the healthcare monitoring systems. And the second one, customer support. So AI chatbot interacting with the customers to answer the query and the resolving to the make the decision. Okay. So what are the customer service agent? Based on the agent, we have to communicate and sharing the information to the that is a customer supported once needed with the what are the queries. And the autonomous vehicles, so self-driving car is the main things of we have to AI, right? So nowadays we have to create in the real time to solving it there, right? Okay, the brake and the accelerator, basically are traffic and the road condition and sensor the data. Then automatically predictive to that and decision making. They have to think about their similar to the human intelligence. That as a AI and make the decision and applicable to the self-driving cars based on the road condition and the sensor with the pattern recognition of the traffic systems. And financially, AI can be analyzing the market trends, predicting the fraud and predicting the stock market and to decision making on the financial analysis. So these are the some other things are we have the various domains. This is called the various domains are can be used in the AI systems there to act as an intelligent way, right? Okay, so healthcare monitoring systems, the customer support, and the autonomous vehicle, and the finance. So these are the things are we have to decided with the, how they are doctors we have to predicting to that. So treated as a human thing that we have to analyzing the data and what is predicted with the similar to this above diagram, how they are thinking with the decision making and the problem solving in the AI. It is similar to the human intelligence. Okay. Right. So what are the main difference for the human intelligence versus AI? Okay, right. So we'll see that this difference creating by the nature. So first one is a human intelligence versus AI. So based on the nature, we have to creating the think about the human. Okay, so creating by the nature. Okay, so that is called the human, how they are thinking and how they are decision making, how they are problem solving. So these all the things are can be act as a human. It is done with the similar to the artificial intelligence. That is called the AI. Okay, so creating by the nature and created by the human. So artificial intelligence created by the human based on the previous data. So assigning the data set. So that the data sets are we have to find out with the which one is the best way. Which one is the traffic conditions, how they are predicting with the healthcare monitoring systems, the autonomous vehicles, self-driving cars, and the financial systems. So various systems are various domains are we have to predicting to the created by the nature. Okay, that is called the human intelligence and created by the human. How they are human think about there is similar to the act as a artificial intelligence. And the information processing is a very slow. So human intelligence, they have to think about everything okay. So created by the nature, but they have processing is a very slow. It is a compared to the artificial intelligence. So artificial intelligence can be processing very fast. Okay, right? That is the main thing part there. information processing by the very slow and the faster. Subjective, it has a human think about the basically we have to, so what are the things are identification. So based on the nature, how they are implemented, all the things. So that things are can be human intelligence. Artificial intelligence being objectives. So only we have to decide with the objectives. So excellent social skills. Okay, so how they are socially interacting with them, how they are socially to excellent to communicate with the sharing the information. So based on the what are the difficulties are to solving the problems in the social skills. So these all the things are can be think about in only in the human intelligence. Right? Okay, but artificial intelligence the below average in the social skills are can be done with their implemented. And the innovation means new idea can be done with the human intelligence. Right? Okay. So based on the innovation, that algorithms are can be provided with the optimal solutions. Optimal solution only can be done with the optimal solution. So this is called the optimal solution. So we have to innovation of the knowledges. Okay. So various knowledges are can be innovative, and these all the things are can be optimal solutions. And the energy efficiency are can be needed into the 25 watts or can be in the human being, human intelligence. The energy can be needed with the, that is the 25 watts. But here there are energy can be needed with the 5 watts only, right? Okay, not in the 25. So only 5 watts. So here the artificial intelligence. And less accuracy and the more accuracy can be results are can be provided. No electricity and the electricity energies are can be needed to power system and displaying with the, all the things. These are the some other things are we have to done with the human intelligence and the artificial intelligence. So created by the nature, that is the first one, and created by the human. So these are the humans and the information processing also very slow. So that is called the faster and the subjective. So mainly we have to done with the subjective. And this AI can be done with the objectives. So excellent social skills are how they are implemented. The average social skills are can be to communicate and sharing the information. Innovative ideas are can be done with that. That is optimization solutions are can be provided. So these things are energy efficiency in a 25 watts. So energy, how their energy can be needed. So they have to think about and the knowledges or innovative knowledges are can be provided. Then excellent social skills. So these all the things are can be communicate and sharing with that the energy also can be needed with the more high. But they have done with the optimization solution only we have to provide it. Okay. So that is a 5 watts are can be needed to energy efficiency. And the accuracies are not provided. Less accuracy can be provided with the human intelligence, but it can be provided with the more accuracies. No need to for the electricity. So there is no need to implement it with the electricity in human being. But AI can be provided with the electricity. It is needed for the more electricities. So some of the basic things are difference between the human intelligence versus artificial intelligence. So this is called the one of the best way to implement it with the human intelligence difference. Yes, right. Then another difference is another things how, what are the aspects of AI versus human intelligence. Okay, next one is what are the various aspects. So learning, under the reasoning, under the emotion, adaptability, under the creativity. So these are the various aspects. So how they are acting with the human intelligence versus AI, artificial intelligence. So learning process, learnings are large data sets can be in machine learning. So it can be act as a large data sets also can be learned. So various aspects of can be implemented with the AI systems. Learning, reasoning, under the emotions, under the adaptability, under the creativity. So these are the various aspects of can be implemented with the AI systems under the human intelligence. So very large data sets can be also implemented learning the data and based on the machine learning algorithms to implement it there. But human intelligence, very minimum levels are we have to think about the experience and the based on the education systems and the reasoning. So solving the problems based on the data patterns. So here solving the problems make the logic and the emotion and the intuition. So these are the basic previous patterns are we have to think about that can be easily to solving that particular problems reasoning. So the logic think about mix the logic think about under the emotion based on we have to solve the problems. Under the emotion, lack of genitive to the emotion under the empathy. The role decision making under the social interactive. So based on the social interactive, we have to think about the what are the things are we have to solving the problems. Then how they are decision making. So these all the things are can be done with the adaptability. So everything we have to adaptability structured problems are will be clear in the data. So not with the adapt to everything. So it can be adaptability wide range of unpredictable complex solutions. So cannot be unpredictable complex solution. It can be easily to solving the problems in a human intelligence, right? But it can be unstructured problems are we have to clear, not adaptability with all the things. And the creativity can be generated with the creating the outputs. For example, art and the music in the AI systems, but it can be creating the inspire of the experience, emotion, and the imagination. So already I shared, no? The PPT also sharing it there, no? AI systems. So these are the some other specific aspects of
your
the
customer আমার কাছে নেই ম্যাডামের কাছে আছে know your customer ওরে বাবা know your customer 5 নম্বরের জন্য দিয়েছি বাবা অন্ত ডাবল know your customer ব্যাংক অফ ইন্ডিয়ার চ্যানেল আছে
Hello. So various aspects of the how to learning and listening and the emotion, adaptability, and the creativity. So AI with the human intelligence. Right, next one. So how they are chatbot. So medical diagnosis using the AI overview functionality and the challenges. So these are the very nice topics are to implement with the AI systems. Chatbots, how they are act as a medical diagnosis using the AI. So what are the things are human can predict to them? What inputs are can be given? So what process to be performed? How they are act as a outputs? So these all the things are how they are implemented into the chatbots. Chatbot with the medical diagnosing using with the artificial intelligence. So overview, functionality, and the challenge. So first introduction with that concepts of chatbot. So AI is a power medical diagnosis chatbots to transforming healthcare provided with the real-time assist and the diagnosis, the support and the patient management systems. So these chatbots are can be natural NLP processing under the machine learning under the clinical database to interacting with the patent. So patients, what are the symptoms under the recommended to the next system? So what are the symptoms under the patients? So how they are interacting with their in the clinical database. So based on this, we have to act as a machine learning under the natural language processes. So how the AI chats are working with the medical diagnosis. So given the user inputs, so patients are can be described with the symptoms that is a text or voice from in AI chatbot. Okay, so these things are I have fever, to cough under the body pains. So what I have to do? So these are the some other examples are can be given with the inputs are in the chatbots. Then immediately chatbots are can be find out is there. What are the outputs are we have to provide it with that and throw it, right? Okay. If it is find out with the processing, next one. So symptoms are can be analysis. A process user inputs to identify the key symptoms. So some other key symptoms are to be find out. So that is a so symptom analysis. NLP processing mainly used for processing user inputs to identify the key symptoms. So fever or cough. So that things are very simple keywords are you should be find out with the NLP. But the main drawbacks are more number of inputs are can be given. That is a NLP is not suitable for that. Nowadays they have to new technologies are can be implemented contextual analysis. So detecting it the urgency symptoms under the sentimental under the contextual analysis. So knowledge based is the so what are the matches symptoms to the medical diagnosis and generating to the problem to diagnose. So we have to what are the problems that can be occurred with the fever or cough. Then immediately we have to matches to the knowledge based. We have to representation. Then we have to throw with the that what are the possible solutions are can be provided. Right? Okay. Then decision making. So machine learning to train the model to analyzing the pattern of symptoms. So what are the symptoms that can be affected to analysis and predicting to the condition flu under the COVID-19. So some other things are we have to predicting to the conditions. So based on the conditions, so what are things are necessary actions to be implemented. So what are the medicines are can be taken immediately. Otherwise, we have to meet with the directly. So emergency situations are we have to directly go and meet with the doctor. So risk assessment to determine need urgent care or home management systems. So if any other situations are very risk management, risk assessment, so very difficult situations, immediately we have to meant to meet with the these all the things are not suitable for only for the very limited levels of human in medical diagnosis. So that things are not that much of levels are implemented over there. So we have to implement it with the home management or urgent care. So determining the need for the urgent care in the home management systems. Called the symptom analysis, under the decision making, under the risk assessment, how we have to find out only medical oriented systems are we have to find out. So how they are output we have to generate the recommendation of the system. So it can be provided recommendation of the counter of the medicines, so self-care advices. So otherwise we have to visit it with the doctor, any other unpredictable situations. So based on the your symptoms, it can be flow under the drink with the continuously we have to rest. If you have fever means persist more than 3 days, we have to consulting with the immediately we have to visiting with the doctors. So based on the your symptoms, we have to some other recommendation of the system. This medicines are can be taken with some other days. Then after we have to over the counter. So counter means how many number of days it can be taken. With the self-care advising. So this is called the self-care advising, and the user agrees to visiting with the doctor or the survey with the symptoms. These are the things that we have to find out with them. So key factors of AI medical diagnosis under the chatbots. Functionality of the chatbots. So symptoms checker under the healthcare edition, under the try agents assistance, under the appointment of scheduling, under the medicines reminder. So these are the some other features are can be used with the AI medical diagnosis. Now, what are the functionalities are to identify the based on this is these are the features to identify the potential health issues based on the pattern reported with the symptoms. So that is called the symptoms checker, right? Okay, this is the potential health issues. So what are the health issues that can be identified, and it also reported with the symptoms. And the health education, providing the educational content based on the conditions, with the medicines and the treatments. So what are the medicines that can be taken? So these symptoms are can be provided based on this condition. What are the main medicines that can be taken? How they are treatment? So based on the healthcare educations for the conditions, the medicines and the treatments. So these are the treatments that can be taken with the immediately, right? Okay, dry age assistance. So patterns, condition, and the recommended to the home care and the professional consultancies. So any other consultancy we have to go and meet there, and the priority based on the patient conditions. So based on the priorities, can be moved from the higher priority means so immediately it can be moved from the consultancy we have to visit and immediately check with the doctors. Otherwise, we have to recommend it to the home care. So based on the priority, so lower level priority means to recommend it to the home care. Okay, so that is called another thing. Appointment scheduling. So integrated to the healthcare systems to book the appointment to the specialist or general physics, general decisions are we have to take into. And the medicine reminder. So send it to the allotted to predict to the medicine schedule. So what are the schedules are we have to find out with that? So based on that schedules can be identification of the that alert into the alert systems. And the mental health thing supported. So based on the physical support to connecting to that, what are the various cases of high risk conditions? So that high risk conditions are immediately we have to go and meet the doctors. Otherwise, we have to symptoms of the other to identification, and we have to take the recommend out of the home care systems. These are the some other things of functionality, and the various challenges are we have to providing the accuracy issues, and the legal and the healthcare concerns, and the limited context, understanding to the data privacy and the human trust. So these are the some other issues that can be assigned to the more challenges, very difficult to identification of the based on this medical data sets are maybe biased or incompleted. So accuracy issues, so that data sets are incompleted or biased into the legal and the healthcare concerns. So need to comply with the registration under the healthcare with the based on the some other things that cannot be predictable. So incorrect data sets are not be so limited context to understanding to that. So chatbots are mismatches to the some other conditions. So only limited fever and the cough or some other things are only limited data sets are we have to find out that some other data sets are cannot be predictable. So that time we have to some other situations are. So that is a very difficult situation to give the immediate solutions. So data privacy storing under the processing the health data are we have to some other risks. So cannot be sharing with another person. Human trust, the patients are not fully trusted the AI at the critical health decisions. So at the critical time, we cannot be predictable. So human trust with that. So human can be detected with some other trust and the data privacy, limited context, under the legal, under the healthcare constraints, under the accuracy issues. So these are the some other things that can be found out with what are the various challenges that can be used to that. Okay, right. So another chatbots, the traffic management system using the AI and the artificial intelligence. And AI with the human intelligence systems. Okay. This is in previously we will see that we discussed medical diagnosis with the AI and the chatbot and the functionality and the challenges. So now next one, very most important topics are we have to cover with the chatbot in the traffic management system using AI and the human intelligence. So first of all, introduction about the traffic management systems. So AI powered traffic management chatbots can be decided to provide real-time updated guidance under the supporting to the navigating the roadway networks. So mainly chatbots can be decided to providing the real-time updates. So what are the real updates under the guidance, under the supporting the user navigating the roadway networks. By combining the artificial network with the human intelligence, these chatbots can be managing the dynamic traffic conditions and the assist to the reducing the congestion and the ensure minimum way of traffic reductions and the decision making to the critical scenario to move to the direction of the without any other traffic management. Okay. So these all the things are we have to mainly predictive to the how they are without any other traffic systems. So effective way we have to move the decision making to things about the easiest way to reaching from the source to the destination place. So how the traffic chatbots can be working. So chatbot means mainly you have to. So chatbot is one of the artificial intelligence. So human can think about how to previous conditions are based given the input and what are the process we have to done on output. So what are the functionalities that can be used. So how they are implementing to the based on the functionality. So these all the things can be provided and done with the executing the output, right? Okay. Right. So what are the user inputs? The driver can given the input of the query. So what is the fastest route to reach to the downtown or traffic way and the highway 101? The inputs can be received via the mobile app and the navigation system or the chatbot platforms. The user wants to enter into the query. So what are the fastest route from the source to the destination places? The traffic in the highway 101. Inputs are received. The inputs can be received in the various places, mobile app. So these are the various ways we have to decide the mobile app under the navigation system and the chat put under the platforms. So these are the some of the things we have to decide with the given the input, the data collection and the analysis. So various way we have to AI processing we have to collecting the data from the source. So integrated with the live traffic data from the source. So GPRS, General Processing Unit Systems, under the IoT sensors on the road, under the real-time updated to the user authorities. These all the things can be predictable. We have the live traffic from the source. So integrated with the AI data collections. So various collections of the data. And the NLP can be used a query to identification of the destination and the route and the constraints. So interpreted with the user queries to identification of the destination. So where the destination of the places, what is the route way, how they are route way to can be road is the traffic or not to analysis with there. Under the some constraints we have to do human interface. Inputs can be traffic controllers or administrators provide updated unfortunate situations. So unpredictable situations, that is accident or events. Yes, certain minutes time before we have to some events can be happened. That is cannot be predictable. We have to move from that way, source to the destination, the best way. But that time we cannot be predictable. So human can be input with that. Okay. So based on the input, they have to predicting the data collections and the analysis. So humans cannot be, they have to not process with the unfortunate fortune situations, so unpredictable situations that cannot be predictable in the traffic. So, and the decision making, user machine learning algorithms are to predict to the model suggest an optimal route. Okay. So we have to suggest it to the optimal route in AI. Considering the historical data, weather condition, and the road blockages. So these are the some of the things are AI can be predictable and decision making. So historical data, previous data, so weather condition, what are the weather condition and the road blockages. So based on these things, we have the identification of the decision making, and the human intelligence valid and overrides the AI to generate suggestion with the emergency situation and the crowd evaluation of the scenario. We have to find out there how they are human can be think about the intelligence, how they are decision making. So what is the processing to analyzing the data collections, and how to solve it given the input of the data. So these are all the things that can be given the output. And the chat box can be responding to the suggestion of the route and the estimation of the travel time. A lot about the traffic jams, accident, and some of the construct of the zones. So these are the suggestion of the routes and the estimation of the travel time, how they are estimated travel times. So in source to the destination places, how they are estimation of the travel times, and allotted to the traffic jams. So everything can be identified, allotted to the traffic jams and the accident, the constructed to the zones. So in previously we have to what are the zones, or we have to some other accident or some other unknown situations are can be identification that we have to construct the zones. Cannot be go for in that way. So we can move from the another best ways to suggestions to the route and the estimation of the travel. So these are the some of the things are given the input and the data analysis, collections of data and the analysis, AI processing, GPRS and the NLP and the human input, traffic controls and the administrators are provided. Unpredictable situations, that is unknown predictable situations are we have to find out how the AI can be try to solve. Yes. So next one. So what are the key features of so what are the key features of AI traffic in a chatbot? So what are the features under the functionality? So route optimization, traffic alert, and the ETA calculations. So ETA means estimation of the time travel. So integration of the navigations. So Google Maps to turn to the guidance, emergency assistance to the multi-modal supporter. So these are the some of the features are in AI. Then what are the functionality? So mainly for the what are the functionalities are can be provided. Route optimization suggests the fastest and the more efficient of route based on the real-time traffic data. So route can be identification. So which one is the fastest and the more efficient of the route? So what given the input of the data? Then what are the data collections under the analysis, under the decision making, how they are provided with the outputs. So that is a route optimization to analysis with the more efficient of the route in the real-time systems. Yeah. And the traffic alert to use the updated the accident under the high congestion areas. So that is a traffic alerts. So traffic based on the traffic alerts. So updated the accident or high congestion area. ETA calculation means it can be predictable. Estimated time travel for the specific routes. So it can be predicted. So how they are estimated to the time travel. So based on the source to the destination. So various where we have to traffic alerted to some other accident or the nearest congestion areas. So that the areas we have to find out to the estimation. So we have to find out the various way. Each and every way we have to find out the ETA calculations. So based on the ETA calculation, we have to move from the best way to travel from the source to the destination. The integration with the navigation. So what with the navigation of the systems? So Google Map to find out the turn-to-turn guidance. So what are the way we have to find out what is a procedure way to move from one places to another places? That is a navigation, integration with the navigations. Turn-to-turn with the guidance. Which way can be moved from, how they are moved from one place to another places. So what is the way we have to go for next identification of turn to turn into the guidance. So emergency assistance. So alert the emergency conditions are we have to traffic manager under the critical scenarios to find out the given the solutions. Under the medical model support to supports the alternative model with the transportation buses or trains. So various way we have to move from the alternative modes, alternative solutions to identification model to the multi-model supporting. So this is adjusted to the alternative modes to transportation that is called the buses or trains or any other way we can be moved from. In this time we have to go for to multi-model supporting. So these are the some of the key features. And the functionalities are can be optimized route optimization and the traffic alert and the ETA calculation integrated with the navigations, the emergency assist and the multi-model supported. Okay. So various use cases and the scenario can be assigned to the so daily communicated with the assistant. So driver can ask you to the which one is the fastest way to work today. The chat books are under the AI can be provided with the real time based on the traffic and the weather the conditions. Human role updating with the unusual condition, unpredictable, unreported accidents. Human role. So human can be we have to maintain it as mother. All the predictable and the all unconditional situation, everything should be maintained. When that particular data sir, we have to find out the traffic, whether the traffic are not, or whether the conditions are can be applied with these. All the things are can be done with that. So based on data representation of the chat book into the data communicating under the assist. So we have to do the some other assist under the emergency traffic management system. Major accidents with the blocks in the highway. So what about the alert to the driver about the alternative routes? Under the human role, the guidance, emergency vehicles, and the ensure the crowd the controls. So these are the things are emergency traffic management system. Even to traffic coordinations. So in cases of we have the heavy traffic condition to detecting the parking zones under the alerted with the exit, then monitoring the crowd safety under the assistant high density area. So more number of people can be staying into the high density areas. So how the air crowd can be monitoring to their safety, we have to move from the without any other traffics to route way can be travels there. And another one is considered direct attendance. So parking to the zone and alerting alternative exist. So the some other events are can be occur with the use cases. What are the technologies are mainly used for can be identification of these things. So NLP processing. So NLP processing under the machine learning, under the geospatial analysis, under the IoT sensor, integrated to the GIS, geographic information systems. Okay. So these are the various technologies are can be applicable in AI. So based on this AI technologies are can be described with the NLP to interactive user query to accurate under the contextual response. So what are the responses we have to provide? Based on the cough or some other keywords are can be occurred means then immediately we have to throw in with some other. So what are the medicines are can be taken? Right? So that is a machine learning can be predictive to the conditions, transactions, and we have the optimal routes are can be find out. That is a prediction based we have to provide. Geospatial analysis, that is a real-time suggestion to the location-based solutions. That is a map. So map, Google Map, we have to providing the geospatial analysis. So real-time data to suggest to the location-based solutions are we have to provide. Under the IoT sensors, so collecting to the various things of the data. So what are the vehicles, cameras, under the road sensors? These are all the information are we have to collect it and find out the maintaining the some other cloud or any other things. So based on that data sir, we have to data processing under the analysis, under the find out with the given the data, it can be predictable or it can be given the throw with the user wants to query the throw the response. So integration with the GI system, geographic information systems are to mapping into the spatial analysis. So what are the inputs that can be given that can be mapping? These information can be mapped. Then analysis with the spatial, then providing the values of the data. Okay. So these are the some other things that can be assigned. What are the technologies that can be used? So based on the technologies can be implemented to description of the AI systems. So NLP mainly used for under the ML, under the geospatial and IoT sensors. So these four important things are can be mainly used for in the nowadays. Chatbots are can be applicable. Machine learning under the geospatial analysis, IoT sensors, and integrated with the GA systems. So what are the various challenges nowadays to providing the AI? So data accuracy with a complex scenario, system overhead, and the ethical issues under the trust and the reliability. So these are the some other challenges. So data accuracy, real-time traffic data can be incomplete or outdated. So real-time traffic data. So incompleted, some other data values are not incompleted. So incompleted data are we have to provide it, or outdated data already completed, leading incorrect recommendation of the systems. So complex scenario AI struggles with the unpredictable human behavior. So sudden land with the changes or some other situation, unpredictable human behaviors cannot be predicted with the complex solution. System overhead, high volume, simultaneously query can go over with the chatbots or can be emergency situations. So we cannot be predictable with the overload. Okay. So some other given the data only we have to throw into the query. So more number of we have to large number of data are we have to enter into the some situations are cannot be predictable. Simultaneously we can't throw into the queries, what are the inputs are can be given and cannot be predictable with the output of the systems. So ethical issues, managing the sensitive data like a user locations under the rises previous constraints. So these are the some other issues that can be after to the managing sensitive data. The trust, always not trust to the handle the high traffic situations without in the human interventions. So trust under the reliability. So cannot be reliable all the time. So some other situations are we have to rely to the AI. So some other situations are cannot be predictable. We have to. So these are some other challenges can be provided with the data accuracy, complex scenario, system overhead, under the ethical issues, under the trust, under the reliability. So these are the main challenges we have to provide with that. So incompleted or outdated data are incorrect recommendation systems under the complex unpredictable behavior system. And simultaneously query we have to throw into the chatbots during the emergency situation. High volumes are very difficult to they have to find out simultaneously. So managing sensitive data like user location and devices to the previous constraints. The trust unbelievable. They are all the times that cannot be predictable with the human interactions. So what are the benefits are we have to use to them? So based on these things are we have to reducing the congestion. Sometimes we have to providing it to the reducing the congestion, dynamic route to minimizing the bottlenecks, and the improving the safety, the real-time alert prevent to the accident and the guidance, emergency response. So real time. So what are the things are we have to activate in preventing the accidents and the guidance with the emergency response and the environmental impact, optimal route and reducing the fuel consumption and the emissions. Cost saving under the fuel for the drivers while driving the infrastructure strain. So these are the some other benefits, reducing the congestion and improving the safety, the environmental impact. So without any other unwanted situations, there can be fuel consumptions and optimal routes can be reduced to that fuel consumption and the emissions. Cost savings. So based on the driver can be traveling to the source to the destination with the minimum route and the minimum travel time can be reaches. So these are the 4 benefits that can be used from implemented with that. How they are reduction of the congestions and the improving the safety and the environmental impact and the cost saving. Okay. So and what are the challenges? So these are the very difficult challenges. Can be some other AI technologies or can be applicable. The way challenges data accuracy, complex scenario, and the system overhead and the ethical issues, runs and the reliability. These are the challenges. And what are the benefits are? So based on these things are in chat. Reducing the congestion and the improved safety and the environmental impact and the cost savings. So example for the interactions. So user, what is the best route for the airport? Then chatbots are can be currently the fastest route in the highway 101. It travels 35 minutes. So chatbots are can be immediately they have to throw into some other send messages. This moderate the congestion nearby the downtown exit. Would you like to alternate route? Yes, they have suggestion with the alternate route user. Then so user wants to enter into that. Then chatbots are can be previous data are we have to store with the some other things. So NLP natural languages processing. It can be matching with the given the data. So based on that matching with the previous data are can be stored with that all the information are can be collected to the they have to display. So that is called the chatbot. Chatbots are can be currently working with the. So we have to find out decision making under the analysis in the chatbot mapping to the system. So which one is the best way in the highway travels 35 minutes, the moderate congestion nearby the town, and would you like to alternate routes? Yes, that is a user wants to enter into the user. Yes, we have to give that alternate route. Then chatbots can be provided with the another way we have to providing the to avoiding the congestion to travel with the 5 minutes we have to do. We like to step by step in the navigation. Navigation means we have to providing to the what is the first procedure of we have one place to another location. Then after another location, then reaches to the destination places. Okay. So future improvement. Advanced predictive models. So this advanced predictive models using the AI under the anticipate with the traffic congestion and the primitive solutions. Enhance with the human AI collaborations under the autonomous vehicle interaction and the voice-based interaction systems are while driving with the chatbots under the free systems the user wants to interacting enabled with the example for interaction system. What is the best way of the airport? The chatbots are can be immediately throw with the, some other things are yes, it can be provided the which one is the fastest way, that is a highway 101 under the 35 minutes. So these 35 minutes are can be calculated with the already I told that is a estimated time travel. So based on the estimated time travels can be predictable. So how much of time taken to throw with the send the messages in chatbot. Then immediately we have to find out that these are the some of the future enhancement, advanced predictive models and enhance the human AI collaborations. So AI anticipate with the traffic such as the primitive solutions, the real-time coordinated with the AI and the traffic control teams, the autonomous vehicle interactions, self-driving cars, and the voice-based. So these are the some other things while driving to the future improvements. So this is a program for chat traffic systems or simulations and using it there and chatbot and the traffic simulation systems. So you'll see the one by one these programs are. So this is how they are entering some other important things. So what concepts are can be implemented? This everything we have to cover in this program. Import record for the libraries. So what are the libraries are can be needed? So based on that, the libraries are can be added to that. Okay. So then from the date time under the importing the date time, importing the random values. So random values are can be generated to that. Then traffic data, real-time data should be artificial intelligence, AI, in the Google Maps and the GPS sensors. So traffic data, route A, the congestion level I, and the ETA. So what about the ETA? ETA means estimation time travel. Okay. So estimation time travel in the route A can be congestion level in a party. Then route B, the congestion level medium, ETA 25. Then route C, the congestion level low, ETA 15. So based on this congestion estimated time travels, so the congestion levels are can be 40. and the conjunction levels are can be medium with the ETA. 25 and the conjunction levels are can be low with the ETA and 15. So based on 3 different ways or traffic data to find out the real time to the AI to the Google Maps and the GPRS scenario. So based on these things are we have to find out the traffic data. So next one is what are the functionalities are can be used to simulating. So defining the human input overwritten. So route suggestions. So what are the way I have to find out with the route suggestions? So major incidents. Okay, random dot choice, true or false. So if I randomly I have to find out the route. Okay, true or false. So major incidents. So randomly decided if there is a overwritten needed. So major incidents, route suggestion of the A, the conjunction level and blocked. So already conjunction levels are can be occurred and the route suggestion to the A also blocked. So route suggestion route A, ETA travels. So estimated time travels are can be based on to infinite time to the block to the data and the print to the human overhead. The major incidents are can be reported in route A, avoiding the route. So return the route suggestions. So why the estimation travel can be high? So because there infinite times are can be blocked with that. So because there is some other major incidents are can be occurred. So these major incidents are can be occurred based on the true or false condition to apply to them. Okay. So major incidents. So randomly choose the true or false. So major incidents can be occurred to the true means that rules are cannot be selected with the. So we have to find out with the overwritten. So major incidents reported to the route A, avoiding the these routes are can be printed. So if conditions are can be applied with the major incidents. So route suggestion with the route A, conjunction levels are can be blocked. And the route suggestion route A, ETA levels are can be find out with the infinite time to the that particular routes are can be blocked. So how they are find out with the infinite times. So estimated time travel. So based on it can be find out with the route A can be blocked with the highest time period. So that highest time period we have to calculate it to the conjunction level. So route A and the route B and the route C. So already I told the traffic that real time would be at API, the Google Map and the GPRS scenario. So traffic data, so various route A and the route B and the route C. So conjunction level I means ETA travels are the 40 seconds and the route B, the conjunction level medium and the estimated time travels 25 seconds. The route C, the conjunction level low, estimated time travels can be assigned to the 15. So based on these conditions, we have to assign it to the route suggestions. Yes. So if the major accidents are can be occurred, then only the estimation time travels are can be increased. Then the particular routes are can be blocked. Okay. So that is called the our main motive of the to print the human override. So major incidents are can be reported to the route A to avoiding these routes. So immediately that the routes are can be suggested. Okay. So what way we have to estimated time travels to can be increased. Why they are estimated time travels are can be increased. So based on the major incidents. If a major incidents are can be occurred there, then conjunction level also can be increased. So based on the conjunction level, it can be blocked with the particular route. Then after we have to suggestion with that particular routes are can be avoided with these routes. Okay, so these things are we have to provide into the functionality of the intelligence route suggestion. So based on the human input overwritten. So that is called the one of the function. So defining the human input overwritten. So passing the parameters. So which parameters are can be passed route, various route. That is what are the route A, route B, and the route C. So then next simulation human traffic control action with the major incidents. So major incidents random choice true or false. If condition major incidents can be occurred means that is called the true. Then after we have to find out if the conjunction level can be blocked. Then what about the ETA? ETA can be increased with the infinite time to blockage. So unpredictable time can be find out with that. So ETA route A can be blocked. So that time that is a major accidents are can be reported with the route A to avoiding with these routes and return with the route suggestions. Returning with the route suggestion. This is called the one of the functions for the simulating the human intelligence. So these all the things are already done with the which one is a chatbots are can be developed with the these are all the algorithms. So what query we have to enter into that, then immediately the suggestions are can be provided in the chatbots. That side we have to write into the all the things. So next one is what are the functionality process with the user query. So defining the process traffic, the user location, destination, and the traffic data. So print the processing the traffic queries, user entering into the destinations. User once we entering into the user locations and the destination. So what about the user locations? So this is called the user location to the destination. Okay, right. Then AI process to analyzing the traffic to suggestion with the best route. So which one is the best route? Find out with that. So based on the best route, if it is blocked, means that it can be providing the removing with that routes. Otherwise, the routes are can be better. If there is no any other block under the ETA travels are can be so better way to reach us with the destination place. Then immediately that can be selected with the best route. So best route equal to route to handling with the all the routes are can be blocked. Otherwise, we have to find out with the best routes. So human intelligent that is a valid to adjust to the recommendation of the systems. So that systems are can be overwritten to identification of best route to minimum level of how their conjunction levels also minimum. So based on the ETA, ETA means estimated time travel. So that the estimated time travels in the traffic data. The minimum level means the conjunction also minimum. So based on that routes also traffic data will be reduced. So that routes are can be selected. So route A, route B, under the route C. So remaining all the routes are can be route A can be blocked, and the route B also minimum level. So low levels are only in the route C. So that routes are can be selected. That routes are assigning to the best routes are to analyzing and given the best route. Then outputs are then generated to the suggestion. We have to find out the ETA levels are can be minimized to congestion level reach to the source to the destination of the places and return to the best way to reach into the traffic management system. This all the process can be done with the query in the chat. Okay. So this is called the chatbot, define it to the chatbots. So print the traffic management system of the chatbot, user location to entering into the current locations and the destination of the entry with the destination place and the route also suggestion with that. Right. Okay. This is a process traffic queries, user location, destination, and the traffic data. So these all the things are can be provided with the result. So result means we have to provide into the best way to executing the all the data. Which one is the best way to implementing the chatbots? Okay, how it is work with the chatbots? So based on this functionality of programs with the chatbot traffic simulation systems. Give the input of the chatbots, accept the user input, starting location and the destination of the location. So your user location that is called the starting location, downtown. Destination place is airport. This is called the input. So you have to give the input in a chatbot. Then after immediately what are the process we have to find out the AI can be, that is artificial intelligence layers or analysis traffic data to find the best route of the conjunction level under the ETA. So conjunction level based on to identification of the ETA. ETA means estimation time travel. So how they are estimation time travel based on to identification of the conjunction level. Then to find out the traffic data, the specific routes are high or not, high or medium or low levels, so that can be find out. So human intelligent layer to valid under the overwritten of the decision to critical scenario can be accident or block to the road. So that also think about their human intelligence layer. So we have to valid or overwritten the decision. So mainly we have to take unpredictable situations or some other being done. So any other situations are like that, accidents are blocked to the road. Then immediately we have to enter into that data to intimate with what are the blocked data. Why we have to particular locations or we have to block it in the particular road. Then chatbots are suggestion with the optimal route and providing the estimation of the travels. All the routes are can be blocked, then user can be referred to waiting for the further routes. A user wants to waiting for that, then immediately recommended to the chatbots. So user wants to waiting for the further updating routes. So if any other updating routes are we have to waiting for the all the systems. So these all the things are we have to providing with the how they are implementing the program in chatbots, traffic simulations. So these are library functions using the library functions. Another one is called the imported with the random. So random level we have to find out with the simulation of the traffic data and the real time of the Google Maps and the GPRS scenario. So based on the traffic data, we have to find out the various levels of routes. So route A and the route B and the route C. So what are the congestion level is I and the ETA, estimation of the travel time to assign it to the party. So ETA travels means we have to conjunction also I, then it can be selecting to the another route way, then route B and the route C. So which routes are can be better, we have to find out there. So based on the major accidents are can be occurred in which routes. So randomly choosing it is the true or false. So that the major accidents are can be happened with the so simulations are to find out with the entering the data, then immediately we have to block that particular route. So it takes a more number of time period, estimation time period. Then immediately we have to assign it to the route suggestion to block to that. Then we have to find out with the another route, avoiding these routes. So then route suggestions are can be wiped out. This is one of the functionalities that can be used to the route suggestions. Okay. Then what are the steps are can be needed to given the user locations, then traffic data, another one is the destination of the place. Then we have to find out with the result. Then chatbots, we have to implement it with the so main functionality of the we entering the data. Welcome to traffic management in traffic and the user locations input with the entering the current location and the destinations and the query traffic to providing to the route suggestions. Right. So these are the way to implementing it there. So traffic chatbot simulation systems. Okay.
नहीं चीज
So thank you, sir. And also, if anybody have any kind of queries, the stage is open for you. And sir, would you like to add something else to this, sir?
Hello, ma'am. How can you share my PPT?
Sir, you can send it to the course coordinator, sir, to
Okay,
Pawan
okay,
sir.
madam. Okay, madam.
So we can now conclude the session, and the next session will be starting at 11:45.
Okay, madam. Thank you, ma'am.
Thank you, sir.
Thank you, Aaron.
Welcome back, everyone. So we are stepping up to the lab session, the second lab session. Yesterday we had a good session with Dr. Vincent sir, that is on machine learning techniques. Today he'll be taking up the lab sessions. Sir, over to you.
Can you hear me, ma'am?
Yes, sir, you're audible.
No. Yeah, good morning, one and all present here. So let me thank once again the organizers of this particular workshop related to artificial intelligence. So in the previous day session, I have covered machine learning techniques corresponds to various predictive as well as classification based techniques. So I hope you will be able to recall that these are all the techniques we have discussed in the previous session with appropriate numerical examples, support vector machine, linear, multiple, as well as logistic regression, naive-based classifier, as well as the decision tree approaches we have covered in the previous session. So we will be looking at the different execution part of how we will be able to implement these algorithms with the help of Python programming. So we are having a lot of privileges in utilizing these approaches in terms of executing this with the help of library functions, because Python is a very sophisticated programming language wherein which we will be able to utilize its capabilities for solving some of the present day problems. So that is what we are going to see today. So before we get into each technique, I will give a brief introduction about those techniques. Then we will be in a position to recall whatever we have covered in the previous session yesterday, and we will be also subsequently see the implementation part. So we are going to implement with the help of Google Colab. As we all know that Google is quite aggressive in AI research, and long back in 2017 itself, they have introduced TensorFlow, which is open for all of us because it is free service for the public. Initially, it was called as Google Collaboratory, and now we will be calling it as Google Colab or simply as Colab. So another attractive feature that Google offers for the developers is the Colab supports GPU, graphical processing unit, which was quite a expensive feature that everybody cannot afford it, and even today the prices of those computers are quite high. So which is totally free for the users with a restricted access even today. So this particular facility is for practicing related to machine learning and data science in the academics and especially for the teaching purpose. So that is what their intention, and so we, the teachers, can make use of it. So we will be able to use Colab for storing our notebooks and ensure that we will be having a Google Drive account corresponds to it, and if at all, if you are having a Gmail account, then we will be have a Google Drive account as well. So where in which we will be able to access this with the help of this particular URL collab.research.google.com. So with this introduction part, we will quickly move into the particular session one by one. So let us start discussing about each approach one by one. So let me begin with support vector machine. So support vector machine, I hopefully you could recall what we have covered in the previous session. So we have been discussing about this particular approach regarding how the optimal hyperplane will be constructed for a binary classifier. So it is basically a binary classifier. So we will be in a position to select an appropriate file for that. So for this particular approach, I have chosen this particular CSV file. So it is a data set which consists of several rows. So for example, we have close to 770 rows corresponds to this particular data set, and we have several columns corresponds to this. Most importantly, this particular data set is about identifying the outcome based on the given inputs, either as 1 or 0. So 1 or 0 means it is purely depends on the particular data features. So there are different features like blood pressure, glucose, BMI, age, several insulin levels. So different attributes are considered for this particular outcome. And yes or no, or 1 or 0, or whatever it may be, we are going to understand from this. This is a binary classifier. So we are going to either classify as yes or no. So that is how we will be considering this particular data sample for our first experiment. So let us look into this particular Python code that I'll be running in Google Colab. So we initially will be loading the libraries that we require for all the coding for different kind of purposes. So libraries are quite common across different programming languages. So for one or two codes, let me explain the library function as well, so that in rest of the programs you will be able to understand what it corresponds to. So the first line is we are importing the pandas as PD. So basically we will be using this particular keyword for the external libraries or modules into our current script. So we will be in a position to use a command called import for importing. And pandas is a Python library which is exclusively for data manipulation and analysis. So for all these kind of stuff, so we will be able to use this particular facility to utilize for our problems. And second thing is we will be in a position to importing different kinds of classifiers, whatever we require in our cases. So when it comes to the next one, we will be able to see to it. We will be able to import the train test split, because as per the Python scikit, we will be in a position to divide the entire data with respect to train and test capacity. So some 70 to 80% of the data we will be using for the training purpose, and remaining amount of data we will be using for the testing purpose. And we will also import the metrics, because all kinds of metrics, accuracy, F1 square, or recall, or precision, all these are belongs to the metrics for a binary classification. So we will be able to use that particular thing as well from the sklan. And finally, we will be even in a position to bring the numpy also. So numpy is basically used for all kinds of numerical computing. So when we are in a position to use numerical based data, so it is well and good to bring this library function also into our program. So these kinds of programs will get executed even without some of the library function itself. But the purpose of bringing many library function is to make us understand the different library functions that are available as part of the Python program. So the first thing is we will be able to execute the library function. So once it is in a position to execute it, so we will be able to input our data set into this particular code for the further execution. So upon execution, so we will be in a position to go for uploading the data. So our CSV file is available for uploading. So here in this particular code, so I am using the diabetes dataset, what I have shown a little earlier with respect to different attributes, and one dependent variable, the target variable is the outcome. It is going to be either 1 or 0. So that particular data set I have uploaded into this particular platform. So now we will be in a position to store this particular CSV file in a new name called PIMA. So we are going to read the CSV file, whichever we have uploaded in the previous command. So if we are going to execute this particular line, so the data set will be stored as PIMA. So just to look into this particular aspect, that whether it is properly stored in that, so we are using this particular command pima.head. So this particular command will helpful for us to not only check whether it was properly stored, but it will also show few rows from the given data set. So we have this particular data set. So from this particular data set, it will be in a position to store. So for example, if I execute this particular command, we will be able to see first 5 rows. Whatever the first 5 rows are there in our data set. So just for the sake of understanding that whether all these are being stored in this particular. So now when it comes to the next process, so we will be in a position to split the data set in terms of features as well as the target variable. So we know that several features are available here. So here you will be able to see all these are features, and this is the target variable. So target variable will be calculated based on all these features from a given particular data set. So we will be able to inform this particular execution that so there are features available with respect to this. So all these we are going to feed as an input with respect to a given variable got feature columns or feature COLS. So now we will be able to make two attributes X and Y. X is going to be our input. So whatever we are getting the input, so that features we are going to provide us. So from the PIMA, whatever we have stored the input data set. So from that, all the features will be stored under the name called X. So that we are going to do is part of that, and Y is going to be the outcome. So in the outcome, so we will be able to store one target variable according to us. So we know that this is the last column, or this is a dependent variable, so that we are going to store as Y. So if we are in a position to do that, then we will be able to move further towards this particular execution. So next one is we are in a position to look into the different aspects of the particular data. So for that, we are going to use another facility called CBON. So CBON is a visualization library. So when you want to visualize something related to that, then we will be able to use this particular library. So that's what we are going to represent as import CBON as SNS. We are going to bring it as a short form. Then we are going to use this matplotlib inline to display the plots directly within this particular notebook instead of opening in a separate window. So we will be looking everything at this particular position itself. Then we will be able to use this heat map. So heat map normally brings us the correlation between one attribute with respect to the other attribute. So whatever the attributes we will be looking at here, so those attributes will be correlated with other attributes, and we will be able to look into what is the correlation, whether it's a negative correlation or positive correlation, and correlation again with respect to what particular extent, so extremely correlating or marginally correlating. So all these things we will be able to see it here. So the correlation factors are given here. So there are 7 attributes corresponds to that, and with respect to each attribute, so we will be able to see with this particular scale. So in this particular scale, we will be able to see all those outcomes, and the values are given here. So if you are not going to give or not is equal to true, then we will only see the colors. So what is the meaning of this color is, if the color is light, then we will be able to understand that it is a lesser correlation, and if the color is going to be very dark, then higher correlation will be there. So that's how we will be able to understand with respect to this particular execution. So that is what we will be in a position to do it here with respect to the correlation analysis. So once that is being done, we will be able to go for the data set splitting. So any particular data set, we will be in a position to work with the handout method. Handout method means we will be in a position to divide the data set into two, one for the training purpose and another one is for the testing purpose. It can be of any particular range, sometimes 80-20, sometimes 75-25, sometimes 70-30 as well. So this is what we are going to do it here. So we are going to do the splitting here by mentioning test size is going to be 0.3, and training size, it will take the remaining value, and this will be truly random. So because it will not choose first 70% or first 30% like that, it will be a truly a random selection. So for that, we are giving random is equal to 1. And then we will be in a position to use the SVM, because that is what we are going to execute as part of this particular exercise. So we are going to again bring from the scale and that SVM. So we are going to import support vector classifier. So if we just place it, we will be able to, so in Google Colab, we will be able to see the details of these particular things. So by doing that, we will be able to use that particular classifier. So we are using the keyword called classifier itself as a variable name. So which is going to use linear one as a kernel, because in the during the session itself, it was mentioned that support vector machine or support vector classifier, also called as kernel machine. So we will be using the linear kernel here as far as this particular process is concerned. So it will try to attempt to separate the classes with a straight line. Yesterday, we have seen that the linear SVM example, where we were able to construct a linear line between the two classes. So that is what we have seen in the previous session. So similar like that, here also we are going to use it. So when we are in a position to do it, we require the training data for the initial training purpose. So we will be able to train this particular SVM classifier, because classifier is the variable name what we have taken from the overall process. So with the training data is being fed into this particular classifier. So that is what it is showing when we execute it. We will be able to see to that particular classifier is being undergone with the given data set with respect to this particular process. So that is what the outcome it says here. So once it is the training is being done, so we will be able to identify how well the performance is with respect to this particular training thing. So always training will be evaluated with the testing data, because testing is something very important with respect to this particular process. So we will be basically calculating the accuracy measure here along with we will be in a position to calculate the F1 square, as well as we will be going for even the confusion matrix. So all these we will be doing as part of this particular metric evaluation for any classification algorithm. So that's the reason why we are importing accuracy score, confusion matrix, as well as F1 score, or anything more than that if we require, then obviously we will be able to do that. So now we will be using this particular execution that what is the outcome with respect to the test data, because only training was already done. Now we are doing with the test data. So this particular classifier will execute with the test data. So when this been done, so we will be able to store it with respect to Y prediction. So that particular Y prediction will carry the results from the test data. Then we will be able to even construct the data and prediction. So actual data of test data will be there. For example, there are 1,000 data instances are there, or 30% means 300 will be there. So among that 300 rows, what is the testing, what is the prediction? So those two values will be already existing value will be compared with the predicted value, and accordingly we will be able to get the confusion matrix from this. So that is what being discussed here. So we will be also printing the confusion matrix here, as well as we will be printing F1 score as well as accuracy score, basically between the testing data and the predicted value. So original data, whichever left out, that 30% data for the purpose of testing, so that will be compared with the predicted value. So that particular comparison will be done. So that is what here we will be able to see to that 133.13. Sorry, let me execute once again. So this particular value is the confusion matrix that we are printing as part of this particular process. And next we will be calculating the F1 square, which is 0.65 or 65%, and the test accuracy is close to 78%. So this is what we will be getting as part of this particular execution. So here after this particular execution, so even we will be able to construct a proper confusion matrix as well with respect to this particular process. So here, if we come down, we will be able to see to that already the confusion matrix was stored as CM. So here we will be able to see to that that particular display operation is going to display the confusion matrix with, we will be able to see false and true are the two labels. So 1 and 0 are the values. So we will be mentioning as false and true here with respect to the outcome. So when we are going to display this particular plot, whatever being calculated from this, so here we will be able to see this whatever the results we got as a confusion matrix format. So here we will be able to relate the true positive as well as true negative, and false positive and false negative. So all these values we will be able to see it in this particular form. So this is how we will be able to execute any particular algorithm, and even we can show it to our students that how exactly a particular algorithm is working. So in the similar way, we will be able to look into all the remaining algorithms as well, one by one, to understand the working principle in terms of its implementation. So in the next, we will go for a simple linear regression. Linear regression, I will show it in two different ways for the better understanding of how this particular approach basically working. So linear regression is an approach which which solve the predictive problem. So predictive problems basically predicting some whole numbers as an output. So in this particular case, so I will be using this particular code for the execution. So let me explain one by one. So first of all, as usual, we will be in a position to import different things like NumPy and other things. So when we are in a position to execute the header files, then we can go for the further execution with respect to the linear regression, or how simple linear regressions are being done. So here I am not going to use any existing data set. So instead, we are going to generate a data set here. So when we are in a position to generate a data set, then we can in a position to generate the way at which we want. That is what being done here. So here, if you see, we are looking for two variables, x and y. X is our input and y is our output. So we are going to fix any number between 1 and 100, a random number. So that will be generated, and it will be also multiplied by 2. So some number will be generated, and that number will be multiplied with 2, and it will be stored as x. And when it comes to y, we are going to store it in a different way. So we are going to store it as 4 plus 3 multiplied by the previously generated x value plus the random number. So that x and y will be completely two different set of numbers. And most importantly, y column will be anything, something related to x. So that's why I am using this particular variable again here in generating the other attribute called y. So that will be also involves with x, so that linear regression will be always looking for the relationship between the input variable as well as the output variable. So that is the reason why we are generating some sample example data in this particular case. So when we are in a position to generate it, we will be, next thing is, once the data is generated, we need to always divide it into training and testing purposes. So here the particular thing is changing. So we will be able to see to that 20% is for testing and remaining is for training. So once that particular part is executed, so we will be able to create a linear regression model. So the keyword for referring to the linear regression is this. So linear regression, we will be calling that particular function, and we are going to store it as a model. So model is the name of the approach through which we will be executing this. So as usual, we will be in a position to train the particular model first. So that's why we are using this a model for fit. We are going to perform this with the training data both from x and y, the already randomly generated train and input values, whatever we have used, that we will be using. So 80% of the x and y values belongs to the purpose of training. So that particular data is used for this particular one with the help of linear regression. So once it is being done, so we will be able to go for testing the test data, which is available in the y-axis. So that particular data, if you are going to take it up, so we will be able to execute it, and we will be able to see to that the execution is done. So it is so simple that how we will be able to execute this. So once this is being done, we will be able to even generate the simple linear regression line with respect to all the randomly generated data. So that is what we are going to do it. So we will be plotting this the regression line in this set of code. So here we will be taking up the training data first, and that we are going to represent in blue color and the label as the training data. So that is the first thing we are doing. And in the second line, so we will be in a position to do that. The testing data we are going to represent in red color, and that is also with the label. And finally, so we are going to plot it, the particular line, we are going to plot it in a black color. So that's why we will be mentioning here, and what is the line width we are going to have, and what label we are going to give for this particular thing. So we are going to plot x-axis, we are going to plot y-axis, and we are going to give the title as a simple linear regression, and we are going to show that. So this particular simple linear regression is given here with all those information what we are going to have. So blue and red lines are visible here, and how closely the regression lines are being constructed. So we will be able to see through it with the kind of visualization that we are applying here. So when this particular thing is to be done, we will be able to see to that how the values are going to be calculated, because for any linear regression, two important calculation is coefficient and intercept. That's what we have seen in the previous session. So when we are using this, we will be able to straight away calculate it, because already the linear regression line itself has been generated after the execution of that particular module. So once it is being done, we will be able to go for the metrics part, because when it comes to metrics of a predictive algorithm, it is necessary to calculate mean square error, root mean square error, all those kinds of values, because we cannot calculate the F1 square or the other measures, whatever we have seen in the classification problem, that we will not be able to do it here. So this is the value of mean square error. So we will be getting some value, and the mean square error, sorry, root mean square error, we are getting one value. And finally, when we are in a position to calculate the mean absolute error, so we'll be getting some value. So this is how we will be able to calculate these things. And from this itself, you will be able to see to that there are several points corresponds to this, and most of the points are very much deviated from the linear regression line. So that is how our random generation data actually works. So it truly generated a random data and not as from any particular data set. So that's the reason why we are able to see a bigger deviation when it comes to these kind of prediction, that we will be in a position to do it. So this is the simple linear regression that we will be doing with a random generation of data. So when it comes to the other way, like by including a data set from the external source, and if you are able to do that, then we will be in a position to do it in a different way. So that is what we are going to see. The same simple linear regression, we are going to see it here. So here, when it comes to this, again, the explanations are given. The y pandas, y numpy, y matplot, cbon, scalan, all these explanations are given here. So everything is a library function. So if we just import those libraries into our program, like from C programming to almost every other programming. So it will be very comfortable for us to work through it. But this Google Colab and all, it is very interactive. So if at all we are getting any errors or something due to the missing library function or something, so it will automatically suggest from here itself. So we will not find it any difficult on addressing some of the bugs or errors that we will be getting with respect to this. So here we will be using as usual library functions what we have used in the previous program. So if we are in a position to execute this, so we will be able to do that. So here in this particular execution, so we are going to use a salary data. So salary data is data set that we are going to use. So we have only two attributes, because it is a simple linear regression. So we can use only one input and one output scenario. So it is just years of experience as one column and salary as the another column. So years of experience is our input and salaries is our output. So this is how we will be able to execute this. So when we are considering this particular data set for this particular execution, so we will be able to bring it that. So after the execution of library function, we will be in a position to upload our data set here. So when it comes to the data sets, already we have considered the salary data for this. So the two column data that we are going to upload here, because it is a very small data, we will be able to see to that the uploading is done in a very quick time. So when it is being uploaded, then you will be able to store the as usual procedure. That particular CSV file there we have stored as PMA. Here it is df underscore sal. So like this particular thing we are using here. So when we are executing this, the data set is going to be stored with this particular variable name. So once it is being stored, so next, as usual, we will be verifying whether all the storings happened in appropriate way. So we are going to use the head function to see first 5 rows corresponds to this particular data set. So that we will be able to see it here. The 2-column data is being listed here for the verification of our uploading. So after doing this, so we will be able to even see this, that another function called describe. So describe is going to give a summary of that particular data set. It will not give 4 rows or 5 rows or something. It will provide us the summary. So what is the summary of this particular execution? So what is the summary here is what is the count with respect to years of experience and salary with respect to what is the count, what is the mean value, what is the standard deviation, what is the minimum value, what is the maximum value, what is the 25% limit, what is the interquartile ranges, 25%, 50%, 75%. So all those quartile values are represented here in terms of years of experience as well as the salary. So here, this will be really helpful for us to understand the data. So what is the data we are working with, and what is the overall view of that particular data? So all those things we will be able to see it here. So next is we will be able to do the salary distribution plot, histogram kind of file, so where we will be able to see the overall distribution with respect to that. So here again, that SNS CBON we are using for any kind of visualization related things. So we are looking into only the salary here. So what is the range of that particular salary, and where the maximum is coming, where the minimum is there? So those inferences we will be getting from this particular execution is what we are seeing as part of this. So next thing is it is going to be another graphical thing that we are going to show it here. What is the comparison between those two columns? So the columns that we are considering here is salary and experience. So when we are in a position to consider that, we will be even able to define the color on which color you want to see the relationship between those two attributes. So that is what it is given. So what is the x-axis, what is the y-axis, what is the title, and all those things if we give, then obviously it will show you that particular graph with respect to these two things. So here we will be able to see to that this particular thing will be helpful for us to understand the relationship between one attribute with respect to the another attribute. So it is quite obvious that once the data set is loaded and we are able to perform some of the visualization tools to understand the data, it is necessary for the execution of that particular data with respect to any particular approach. So here we are using linear regression as our approach. So first thing is, we will be splitting the data between the first two column as well as the second column as independent and dependent. Then we will be going for dividing the particular data. So here also we will be in a position to use the given data set as 80-20, because 0.2 or 20% is what we are assigning to test data, and remaining 80% is for training data. So here we are going to mention random state equal to 0, which means it will not be choosing the data in a truly random manner. So we will be in a position to see to that it will be selected in a sequential manner. So once the splitting of variables are done, and the other thing is we are going to divide the training and testing data, straight away we can go for, first of all, the training process. So training data will be taken into this particular regression process. So we will be defining a variable called regressor for the linear regression. Then we will be in a position to execute this, where we will be able to train the data with the help of linear regression algorithm. So after doing so, we will be able to go for the prediction results. So when it comes to prediction, obviously it needs to be predicted from the tested data, and sometimes we can even verify the training data as well with respect to that particular prediction process. So we will be able to show the linear regression line, whatever we have generated in the graphical manner. In that case, we will be taking both the uh, data, whatever we have used for the training purpose. So that is being represented a particular color compared to the regression line. Then we are going to display all these things as the x-axis, y-axis. So all those we will be doing here. So when we are in a position to do this, we will be able to see to that the regression line is formed in this particular way with respect to all the available data within that particular range. So similar like the previous problem, once the regression line is being formed, even we will be able to get the values of regressor coefficient as well as the regressor intercept. So those two values are important for the calculation. So when we are in a position to execute this, so we will be able to get those values, the coefficient and intercept value. So soon after doing that, the only step left out after any execution of algorithm is to calculate its metrics. So how the metrics of this particular approach goes with. So as it is not a classification based approach, so we will be doing this with the help of different metrics called R square, mean absolute error, mean square error, and root mean square error. So here we will be able to look into those particular values, whatever being calculated. But accuracy or the R square method is quite good when compared to the previous approach, because here itself we are able to see to that the data is not that much parsed compared to the previous example. So we are in a position to get a very good R square value with respect to this particular execution. So that's all about the simple linear regression with respect to its implementation. Next, we will be able to go for multilinear regression, because multilinear regression we have discussed in the previous session, that linear regression takes only two values, one input value and one output value. So probably we will be going for multilinear regression if our features are more than two. So here we are going to choose another data set for this particular multilinear regression. So here in this multilinear regression data set, if you are able to see here, you are able to see there are 4 attributes are there. So there are 3 attributes, input attributes are there, and 1 output attribute is there. So from this, we will be able to understand that it is a problem which require a multilinear regression model to solve it, because first of all, it is a prediction problem. Outcome is going to be a numerical value. And second thing is more than one attribute involved in this particular example. So it is necessary for us to use this kind of particular thing when it comes to the particular problem solving. So here, if you are going to execute that, so as usual, we will be in a position to use the library function for the initial thing. So here, since many sessions I have used for the different things. So it is necessary to terminate it, because it will not proper multitasking thing. So it will allow only few programs to run at the background. So I have terminated already executed things. So when it comes to the library function, so here we will be able to execute it for as an initial thing. As always, we will be able to do that. And here again, I'm going to read the input from the outside source. So here, as I have already shown the particular data set, advertising is the name of the data set. We are going to use it here. So which is actually required because it is a multi-linear regression that we are using here. So if the particular data set is being stored it is necessary to read that particular data set, and here we are going to store the data set with the name same as data set itself. So if at all we are going to store that, we will be in a position to see to that head function will be showing the first 5 rows of that particular data. So here itself we will be able to get the glimpses of the data, that there are 3 attributes are there and one final outcome that we are going to get as part of this. So this is how we will be able to get. So after having this particular thing, so we will be able to again go for the heat map. So heat map we have earlier seen in the support vector machine example, because there also we involved many attributes. So after that particular example, here only we are using different attributes. So we will be able to look into all those things. So that's why this Seaborn based SNS is being used for as a visualization tool for understanding the correlation between different attributes. So this particular heat map is not only representing the values, but also representing a color which shows an appropriate thing with respect to what kind of correlation it is, whether it is positive or negative, those kind of things. So this is just to understand the data. So next thing is for our execution, we require the data set to be divided into 2, which is the first one is the input attribute. So according to this particular example, 3 attributes are there taken as the x-axis. Sorry, not x-axis, that input attributes 3 are being taken, and the output attribute sales is being taken as y attribute. So we will be able to store it as x and y with respect to the input and output. So soon after that, we will be able to splitting the data set, because it is obviously necessary to divide the data into training and testing. So again, in this particular example, we are coming back to the training and testing in terms of 70% and 30%, like the support vector machine. In the previous 2 examples, we have seen that only 80 and 20 that we have used. So here we are using 70-30. So if you are going to execute that, the entire data set will be properly divided as the training data as well as testing data as per the commands that we are executing. So once it is being done, it is necessary to execute this particular thing, multi-linear regression model. So when you are going to do that, it is necessary to again store it as a particular variable name. So once it is being stored, we will be able to execute with the training data, because in all those executions, you might have noticed that we have to execute this with the training data first, then only we will be going for the further things. So when it comes to the coefficient and intercepts, it is necessary for us to know what is the calculated value as per the training data. So here you will be able to see to that there is only one intercept, but since there are 3 attributes or 3 variables corresponds to this particular data set, the coefficient of each data attribute is being calculated here for the 3 attribute called TV, radio, as well as newspaper. So those values are being displayed here. So once it is being done, then we will be able to move on to our prediction next. So how we will be able to predict the test case with respect to the 30% of data. So we will be able to execute this with the help of the test data, and the prediction for test set is being given here. So out of total number of data instances, 30% of the data instances are taken into consideration for the test data. All the test values are given here. So whatever the value, so this may be deviating from the original, and that we have to calculate as part of the metrics. So we need to calculate the metrics corresponds to this particular execution. So if we go for the actual and predicted value with respect to some of the things, because we have executed, so that's why this particular is being done. So here we will be able to see the actual value and the predicted value. So actual value is 16.6, predicted value is 17.8. So vice versa, 4.8 and 5.15, 7.6 and 7.8, like that. We are able to get some close value as the predicted value were compared to the actual value. So that is what being seen here with respect to this particular model. And finally, the most important thing is evaluating the model. So how accurate this particular model? So this is looking like a real-time model where some 4 attributes are there with respect to our data set. So we need to understand what is the deviation, what is the accuracy, and all those things. So that's the reason why we are using this particular function, sklearn, which imports the metrics. So we will be able to calculate mean absolute error, mean square error, root mean square error, R square value. All those values we will be able to calculate as part of this execution. So, so here we will be able to see to that we are getting an R square value of 90% or more than 90% we are getting, and all our deviations, the errors are between 1 and 2. So that is how we will be able to execute this particular model, and we will be able to see to that the performance of the model is going to be a good performance or average performance or below average performance. In that way, we will be able to conclude with respect to these particular models. So this is what the end of multilinear regression. So next we will go for logistic regression. So logistic regression, as we have seen in the previous session, that it is again a classification based algorithm. Unlike the linear regression, so here the logistic regression will be trying to give us a calculation between these two aspects. So here, as usual, we will be running all the header files, which includes the logistic regression, metrics, and the train test split. All those things we will be able to bring it from the library called sklearn, where we will be able to bring it. So that is what being returned first, and we will be executing that very first. So next, again, we are going to apply this particular task of how we will be able to generate the data as part of this logistic regression. So as usual, we will be in a position to generate the data like the linear regression example that we have seen already. So after the generation of data, we will be able to split the data as a training and testing. So once it has been done, we will be able to bring the logistic regression model or algorithm, because it is just a single line of code. So once that is being stored, we will be able to further divide the data set into training and testing, how we will be able to do that. So once the training data is being executed with the help of that, it is necessary to make predictions based on the test data. So the test data is being executed here, where it's the logistic regression is able to predict from the text data. And most importantly, so here we will be able to calculate the accuracy. So unlike the other prediction model, so here we will be able to calculate the accuracy. So accuracy measure that we are getting out of this particular exercise is 80%. And we will be also able to calculate all sorts of metrics like precision, recall, F1 square, everything we will be able to calculate it. So that is what we will be getting one after another with respect to the calculation with the help of logistic regression. And you will be able to calculate the confusion matrix as well, because it is a small amount of data that we have generated. So we will be getting some good results with a small number of values available in the confusion matrix. So that is what we will be able to understand from this particular exercise. So after the completion of this logistic regression, so we will be able to look into the next approaches, polynomial regression. So polynomial regression is actually not covered in the previous session. So I just want to briefly explain what is that polynomial regression. Then we will be in a position to look into the particular execution. So polynomial regression is also based on the regular regression, whatever we have seen so far. So if you can recall, regression is going to have a relationship between input and output in any of the linear equations. So linear equation like y equal to mx plus c or anything related to that with the number of coefficients. If the number of attributes are going to be high, then we will be able to understand that it belongs to the multilinear regression. But polynomial regression is something different where we will be not seeing any linear relationship between that. So only linear relationship between two variables or variables are available, then only we will be able to use the regular regression techniques. If we are in a position to see some non-linear relationship between these kind of attributes, then our option of working with the polynomial regression model is the solution for handling that kind of data. So here, if you are able to see this particular equation, so y equal to beta naught plus beta 1 multiplied by x, then beta 2 multiplied by x square, beta 3 multiplied by x cube. So these are all not a linear relationship, because 2 multiplied by something, 5 multiplied by something, that only we will be considering as a linear relationship. But these kind of exponential operation will not be considered as a linear relationship or something like that. So that's the reason why we have a separate approach called polynomial regression. So polynomial regression, if you are in a position to do that, we will be able to work with this here. If you can see, we will be able to implement this with the library function, whatever we will be having with respect to this particular execution. So as usual, execution like every other programs. So once it is executed, so again here going to generate the data here. So as we have seen in the PPT, that the relationship between x square, x cube in that particular way. So that's why we are particularly generating the outcome value y with x square. So x square, we are bringing it in a very appropriate way that we are going to execute with the help of polynomial regression. So that's why we are generating the second column of data with the help of this x square function when compared to the input value. So once this data are being generated, so we will be able to always split the data into 80% and 20% with respect to this particular execution. Then we will be able to bring the polynomial features with respect to that. So here we are using the degree of polynomial equal to 2, because maximum the square value we are considering with respect to this. So if at all we are able to do that, we will be able to get both the training data and the testing data for this particular execution, because that polynomial features are being stored under this particular name called poly underscore features. So that we will be able to get it for the execution. Then we will be in a position to bring it to the poly model with the help of linear regression function, with whatever the training data what we are going to have. Then based on that, quite obviously we will be in a position to apply the test data after the training process gets over. Next thing is we will be able to get the polynomial regression line. So polynomial regression line is important for us, because in every regression problem, we will be able to construct the regression line with respect to that. So when we are in a position to execute this, we have generated. So the particular one, we will be able to show it as the label. So the colors are being represented and how the transforms are going to be using the x-axis and y-axis. So here you will be able to see to that. So x and y, original data, testing data, everything is represented. And most importantly, the polynomial regression line. So polynomial regression line is being constructed here, the black color and line width of 3. So if you were able to see it here, it is not at all a linear line. So we will be able to see a truly non-linear line which connects between the input and output which are being represented with respect to that. So that is what represented as x-axis and y-axis, and the blue and red are actually representing the original data which was used for the purpose of training, and the red is representing the testing data that we have used for training this particular model. Once this particular model is being trained, so we will be able to see to that what is the deviation, because errors are the one which is going to tell us that how successful this particular implementation is. So if we are going to execute this, we will be able to get the mean absolute error as well as the mean square error. So whenever we are working with the randomly generated data, so we will be getting the minimal accuracy measures when compared to the actual data. So that is what here also we are able to see with respect to this. So that's all about the different types of regression. So just to recall, what are all the different types of regressions we have discussed is simple linear regression, multiple linear regression or multi regression model, logistic regression model, as well as polynomial regression model. So all these we have covered so far in this particular session. And the next model that we are going to see is the naive-Bayes classifier. So naive-Bayes classifier is a probabilistic approach which will be solving the particular problem with the help of a probability-based theory. So where we will be applying the Bayes concept on calculating the posterior probability. So posterior probability will be calculated based on the various factors that we are going to present, and accordingly the final outcomes will be calculated. So here we are going to consider this particular data set which consists of 3 attributes: age, salary, as well as purchased or not. So this is again a binary classifier. So after being some time we are discussing about this, so we will be in a position to see to that how things are being done. So now we will be able to look into this particular example. So this particular example or exercise is going to use the naive-Bayes classifier for this particular execution. So here we will be able to see to that as usual the the header files libraries are being used here. So we will be able to execute those things. So when upon execution, so we will be able to move into the loading of data. So unlike the regression based problem, we will be able to understand that how things are going to be moving ahead with respect to that. So yes, so as usual, we will be loading the data set from that. So already I have shown the data set which consists of 3 attributes called age, salary, and the information regarding purchased or not. So this particular thing, so we will be in a position to do it for the uploading. So since all these file sizes are very small, the uploading is happening so quickly. So again, the as usual procedure. So we will be reading the particular data set into the name as data set itself. So here, instead of head, we will be using tail as the keyword for looking into that. So if we are in a position to execute this, so we will be able to see to that last 5 rows of the particular data set is being listed here. So here it is just to verify that whether the data set is properly captured by this particular variable. So that is the purpose of doing this. So after doing that, again, you would have noticed that there are 3 attributes are there. So when 3 attributes are there, we have to properly write a code that first 2 attributes are input attributes or features that going to give us an input, and the last attribute purchases our output variable or the target variable. So that is what being represented here with respect to this particular execution. So that is being done here. So next is quite obviously we will be able to look into the other kind of visualization tool, for example, the correlation thing. So between the correlation, what we will be able to do it. So because there are 2 attributes only here, age and salary is there. What is the correlation between age and salary? So here we will be able to see to that because it is only 2 attributes. The correlation between age and salary or salary and age is going to remain same. So there is a correlation, and most importantly, there is a positive correlation between that. So that is the takeaway point from this particular execution. So next, again, we will be able to look in for one more visualization tools where we will be able to look into these aspects as a bar chart. So those details we are seeing because the target variable here is purchased. So how many number of purchased data is there, how many number of not purchased, so how many number of rows, that we will be able to see it here as a bar graph, so that we will be able to understand what is the kind of relationship between the balance of the data. Because sometimes if the data is not balanced, imbalanced data means we may not be able to expect a very good performance corresponds to that. So for that particular case, we will be doing that. Then obviously we will be splitting the data into training and testing. So training and testing here, unlike the previous cases, so we will be dividing as 25-75. So 25% for testing and 75% for training. So that's what we will be able to do it with this. So here we will be using or bringing the naive-based classifier here. So that is why we have introduced a library function by introducing Gaussian naive-Bayes for handling this particular problem. Being stored as classifier 1, the name of that particular variable for storing that particular function. Then we will be very first executing this particular classifier with the training data. So once the model is being trained with the help of this, obviously we will be going for predicting the outcome with the testing data. So that being that this particular line. So once this training and testing has been done, so we will be always in a position to go for the metrics. So what is the accuracy measure? Because it is a classification based approach, so we are getting the accuracy measure here. Because here the selection is going to be truly random. So earlier 89% was there, now it is reduced to 88%. So we'll be getting more or less the same kind of results with respect to this, because the data set we are using as the same one. So here, based on the accuracy measure, even we can go for the confusion matrix. So confusion matrix, again, another graphical representation that we are going to use it here. So for that, we are using the library function as a cbond. So for representing the confusion matrix, like the previous cases. So here also we are going to give 1 is equal to true, which means we will be getting the values in every boxes while we print that particular thing or when we plot that particular thing. So when it comes to the classification metrics, obviously all those metrics are something very, very important. So that's why here we are going to get the classification report between the testing and prediction that we are going to have. So here the measures are going to presented with class wise. So 0 is one class, one who not purchased, and 1 is another class one who purchased. So we will be able to see to that the accuracy measures are being listed here with respect to the precision, recall, F1 square, all those values are being given here. So that is what the overall accuracy is also listed here when compared to the previous models, where classifications are always comfortable in handling with different metrics to understand how well a particular model is performing. So before we wind up this particular thing, so we will be in a position to see even the ROC curve. So ROC curve is also another important measure to understand the relationship between true and false positive rate with respect to this. So this particular ROC curve, we are going to plot it with the help of whatever the testing data we have used. So here the representation, colors, label, and all those things, plot, titles, label, everything we are going to give it. So this will be really helpful for us to understand the performance of the overall algorithm. So this is what is being given here, that more than 80% of the contents are going to be very accurate between these two kinds of comparison between true positive and false positive. So we will be able to understand the overall performance in a graphical note as well. So if basically we are writing a research paper based on classification and all, so all these are mandatory things when it comes to the metrics, result, analysis part, ROC curve and other things are going to be the mandatory one when we are going to write a research paper. Even for students, we can give the glimpses of all these kind of analysis. So that's what about the naive-based classifier that we have discussed in the previous class. So next we will move to decision tree. So decision tree also we have discussed in the previous session itself. Whatever we have discussed in the previous session, we will be able to execute here, and we will be able to see to that how things are being done with respect to that. So for execution of this, again, we will be selecting the diabetes data with respect to different attributes, that how decision trees are basically constructed out of it is what we are going to see as part of this particular discussion. So again, header files, we will start with a lot of libraries that we are importing for the smooth execution of all our codes. And once the libraries are being loaded here, then we will be able to move into importing the data set from our device. So in a simple way, we will be able to bring our data set here. So data sets are very small, so we will be able to load it very quickly. Then similar like the support vector machine, where we have already used the diabetic data set, here also we are using with the same variable name PIMA. So that we are using, and this head function will be helpful for us to see to that the particular data set is properly brought into this particular variable called PIMA, and 5 rows are conveying us that how good this particular things are happening. So when it comes to this particular correlation comparison, so since we have already done with the correlation values and all, so here I'm not giving a not equal to true. So here the various colors, the purpose of showing it here is the various colors is also part of this particular analysis, and the colors are being generated based on the correlation value. So in order to make all of us understand, so this particular thing is done without those annotated values. So once the data is being done, then it is quite obvious that we have to give, because there are many attributes corresponds to this particular data set. So hopefully you remember before also we have used this during the support vector mission. So there are 8 attributes are there which decides the dependent variable or the target variable outcome and particular case. So all those things we are going to represent here as the input attributes for X, and the output attribute Y will be handling only with respect to the outcome. So the target variable we are going to have corresponds to this. So that is how we are going to divide the inputs for different attributes or different variables. So soon after that, we will be able to do the splitting, the handout method splitting. So here again, we are going with the 70-30. The test size we are going to represent 30%, and again here the selection is going to be a truly random one. So randomly we will be selecting this for processing this. So we will be able to see to that if that is being executed, then we will be able to perform the training data set to be executed. So here we are using decision tree classifier algorithm. So decision tree classifier basically working with respect to this particular thing. So we are using CLF as a keyword or the variable name for getting the decision tree classifier code. So with the help of CLF, we are going to initially work with the training data. Then we will be also able to work with the test data as well. So training and testing both will be done with respect to this. So once training is done, then we will be expecting that testing will be obviously do the comparison between that. So when we are going to identify the model accuracy, so we'll be able to identify that the testing accuracy is close to 69%. So this particular accuracy measure always tells us that hopefully you remember we got close to 90% accuracy with respect to support vector machine. So here we are getting little less. So apart from whatever we have shown so far, here we are going to go with different types of code, that is pip install of graphical things. So here, unlike the previous one, we are going to use a visualization tool in a graphical manner, because the thing what we are going to generate is a tree. So tree needs to be generated and it has to be displayed as a tree-like structure. Then only we will be able to understand that. So for that, we will be using this graphical tool for the visualization of graphs and trees. So we have to use this particular thing. So that is what it is being given here. So again, another PyDot Plus is also, we are installing that particular library also for supporting this GraphViz. So again, we are installing 6 also, so which is going to be a compatible tool between Python 3 and 2. So all these are necessary for executing this. So once we are in a position to construct the tree, it is necessary to run this particular code as part of the generation of the code. So anyway, already we have calculated the accuracy. It is necessary to look into the tree which is being generated, because there are many attributes are there. In the theoretical session, we have taken 2-3 attributes for the construction of a tree. So here many attributes, 8 to 9 attributes are involved in this particular tree generation. So that's why we are using this. So here this code is for doing that, how we want to look into the particular tree. So here this is the tree which is being generated from the given data. So just look into this, how big the particular tree is for just 8 to 9 attributes that we are able to see. So this is what the generated decision tree as part of this particular exercise. So we will be in a position to apply a entropy based technique also by having only depth is equal to 2. So as we have discussed as part of our previous discussion, we have discussed about tree pruning. So tree pruning, if you are in a position to generate a very complex depth tree, obviously your accuracy will be very much reduced. So in that case, we are minimizing the tree with respect to a very less number of depth of the branches of the tree. So by doing so, when we again calculate the testing accuracy is improved substantially from 68% to 77%. So that is what we are able to see with respect to this particular execution. So upon doing that, we will be able to even approach the classification report along with the confusion matrix. So here we will be able to even see the accuracy class wise, that 80 and 71 are the two accuracies we will be getting with respect to that. Even this particular thing, we will be able to look into the confusion matrix as well. We will be able to do that. And we will be also able to execute the ROC curve as well when it comes to this particular execution. So ROC curve, we will be able to look into that, how well we are able to see. This is unlike the previous exercise that we have seen in naive-Bayes classifier. So here it is not so between the false and true positive, right? So from the ROC curve itself, we will be able to see to that the performance is not up to the mark when compared to the previous approach. As we all know that decision trees are prone to overfitting problem, and somehow the particular problem is addressed with the help of this, but still we are able to see to that it is not up to the mark, because the accuracy measure ranges somewhere between 76 and 77%. So that is what we will be able to see through this particular example. Then we will be in a position to go for the next model, that is decision tree regressor. So decision tree regressor means, in the previous class we have discussed that decision trees can be used for both, which means for the classification problem as well as for the regression based problem. So in that particular connect, we are going to execute this particular coding for a regression based problem, because we will be looking for something, a continuous value. So for that, we are choosing this particular data set, which is the petrol consumption data set. So this particular data set, if you see the target variable, it is a continuous value. So unlike the classification based problem where we will be end up in getting some of the classes as 0 and 1 or something like that. So here we are getting this particular data set with a continuous value. So we are going to work with the decision tree regression based problem with respect to this particular chosen data set. So as usual, we will be executing the header files for the libraries to be imported into the execution environment. So that we will be doing very first. So then we will be in a position to bring our data set into this particular environment. So this particular data set, just before I have shown, so we will be able to have different attributes like petrol tax, average income, paved highways, population, driver license, some data set which has an outcome of target variable with respect to some continuous value. So after the execution of this, obviously our next step is to read the data into a particular variable. So here we are considering data set as the name of the variable. So once we will be able to do that, obviously the head function will give us the first 5 rows of that particular data set. Then we will be able to move for the describe as well, because this involves many data attributes. So describe will give us a complete idea about a particular data set in terms of its count, mean value, standard deviation, minimum, maximum, different quartile ranges, 25, 50, 75. So those measures will be provided to us with respect to this. So next thing is how we will be able to go for the further things of how we will be able to take up the inputs and outputs with respect to x-axis and y-axis for this. So when we are in a position to do that, the splitting is our next thing. So we will be able to bring it 80-20 with respect to that. So the model or the algorithm or the approach that we are going to use here is a decision tree regressor. So that particular model, if you are going to use it, we will be able to use it over the training data. So similar like every other program, here also we are going to do that. So when we are going to do that, it is possible for us to next go with the testing data, because once the testing is being done, we will be able to go for the different metrics. So the test data is being predicted here, and accordingly, so we will be able to calculate the different metrics: mean absolute error, mean square error, root mean square error. So all these values we will be calculating from the test data, and we will be able to show the results as part of this. So this is not a classification problem. So we cannot calculate the regular metrics like the normal F1 measure or recall or precision. So those kind of things here we will not be able to do it. So we will be able to do with respect to that. So with respect to the trees, always we will not stop at this particular point after testing the data, but we will also use similar like the previous example of how we will be able to construct the particular tree with respect to the given data. So that is what we are going to do next. So our data is being stored here with so various inputs, whatever required for the construction of that particular decision tree should be given from this particular part. Export graph is if we are using this. Similar like other things, so we will be able to provide all the inputs required for that. So if at all we are going to execute this, so we will be able to get this particular tree. So this particular tree is being generated from the data whatever we have received as part of this particular thing. So it is a very complex and a very lengthy tree that probably we used to get as part of any particular decision tree based approach. So that is what we are able to see at part of this. So similar like other approaches, here also we will be dividing training and testing, executing training separately, testing data separately, then the metrics we are calculating. Then in addition to that, we are in a position to look into the generated tree also, because it is a structure that we are able to easily understand and interpret. So as part of that, we are able to see to it. So this is what we have discussed in the previous session, all types of approaches, including support vector machine, regression based approaches, naive based classifier, decision tree based approaches, all those we have discussed. So I just want to show two more coding as well as part of this machine learning based. So I feel any particular machine learning syllabuses will be having these two algorithms as well. So that's the reason why we are going to have this. So the next one, what we are going to see is k-means clustering. So k-means clustering is a unsupervised learning based approach, so where we will be able to bring the unlabeled data for handling these kind of things. So not only for that particular case, even with the labeled data, we will be able to create a different clusters based on its similarity and all those things. In a simplistic manner, we will be able to understand that any k-means clustering will be working by considering several center points. So center points, we will be also calling it as centroids. So for a two cluster problem, we have to select two random middle points or center points or centroid, and based on the chosen value, so we will be able to calculate the distance measure with respect to the other points which are available as shown in this particular example. So if you are considering the first point 1, 1 as well as the fourth point 5, 7 as the two center points, so we will be able to calculate the distance with respect to every other point. For example, 1.5 and 2, if you are going to consider as a particular data instance, then we can use the Euclidean distance formula for the calculation of the distance value. So here 1.5 and 2 is compared with both the centroids 1, 1 as well as 5, 7. So based on the two Euclidean distance based calculation, the distance measure shows that 1.12 is a smaller value compared to 6.1. So 1.12 is a smaller value. So 1.5, 2 belongs to the first cluster, that is 1, 1. So similar like that, all these values will be calculated and we will be able to create appropriate clusters. Here, according to this particular example, we have to create two clusters out of these kind of things. So we will be able to create two clusters from this. That is what we will be able to understand out of it. So with this particular thing, so here you will be able to see to that all the values are tabulated here with respect to different center points. So whichever values are lesser, we will be in a position to group into the appropriate cluster based on the distance measure or based on the similarity measure. So that is what we are going to see here, even in this particular coding, that how we will be able to do that. So again, we are going to use this particular code. So here for a change, so we are going to use some of the already existing data set which is from here. So that's why we are going to include this iris data set for this particular calculation of consideration of a k-means clustering algorithm. So we are going to use the inbuilt data set of iris data set from this particular platform itself. So we are going to use that. So initially we are as usual running the header files for importing the libraries here. So upon importing the libraries, we can directly load the data set here. So here we are not neither generating the data set nor we are storing or exporting or importing from the device, but we are going to use the inbuilt data set here itself. So that is what the iris data set we are going. So here in this k-means clustering, so we are going to consider k value is equal to 3. We are going to create as part of this particular execution. So here we are going to because in clustering and all there is no metrics we have like accuracy or any other things and all. So only thing is we will be in a position to calculate the cluster center points and we are going to assign different points here, and most importantly how we are going to visualize things. So based on the visualization, we will be able to see to that whether these clusters are being formed appropriately. So that is what we are going to see as part of this particular exercise. So this is how we are going to plot here. So while plotting this, several things we need to take care here. So first thing is the center point. So all the center points are represented as X here. So that is what being represented in this, as well as we are going to see all these in a different colors. So three different clusters we have created and those cluster points are being given here, and the cluster points are being created between two different attributes called sepal length and sepal width. It is part of the iris data set. So with the sepal length and sepal width which are in centimeters, it is in a position to create 3 different clusters as part of this, and we will be able to see to that there are proper graphical visualization is given in this particular approach. So yeah, very, very simple thing because K means clustering. Probably we will be using for segmentation or something like that, where in which we cannot have training data, testing data, we cannot have metrics and all those things. So just we can apply this particular approach, as well as we will be able to visualize our results in terms of in a 2-dimensional plot or something. So this is how we will be able to do that. So that is what about the K-means clustering. So before I wind up, one final algorithm that I am going to show here is principal component analysis. So principal component analysis is not a straightforward machine learning approach to solve some of the problem, but principal component analysis is a dimensionality reduction approach. So dimensionality reduction approach means any particular data set, if you are going to take it up, we will be in a position to apply pre-processing techniques. So pre-processing techniques will be helpful for us to prepare the data. So during the preparation of the data, we will be in a position to select the features. We will be in a position to go for the data correction, handling the missing values, wrong entries, all those anomalies we will be trying to apply. But sometimes when we are not in a position to do feature selection, so we will be in a position to go for feature extraction. So how we will be able to extract the information from the given set of features, still we will be able to reduce the number of attributes. So let us take this particular example. So this particular example is consist of some 9 attributes. So 9 attributes are considered for rating a particular city. So called climate, housing, health, crime, transportation, education, arts, recreation, economy. So all these are so such kind of data set if you are working with, we will be able to understand that all these attributes are important attributes. So we cannot simply leave one particular attribute while rate a particular city. So all are important in different perspectives. So we cannot say that one is very important and another one is least important. So all are important in different perspectives. So in that particular case, we cannot go for a feature selection here. But at the same time, if I want to reduce the number of dimensions, so I will be in a position to use principal component analysis. So principal component analysis will give us a projection from all the 9 attributes into the value. So here we will be in a position to get PC1, PC2, 3, 4, 5 like that. Principal component 1, principal component 2, 3, 4, 5, and so on. So when we are in a position to generate this, we will be able to understand that principal component analysis will preserve maximum information from the original number of dimensions. If there are 9 dimensions are there, when we are reducing it to 5 dimensions, so we will be able to ensure that maximum possible information is preserved with respect to these 5 dimensions. In an approach will be really helpful on solving some of the problem which is going to have higher number of dimensions. So this is what the principal component analysis approach that we are discussing about. So principal component analysis is the last approach. I thought of even covering K nearest neighbor approach, but it is something very basic when compared to the other approaches. So I am not going to cover it up by considering the time. So principal component analysis, again, we are going to work with the same iris data set. So just for our own understanding. So as usual, we will be executing the, we are executing the library function. So library function itself is importing the data set, that is iris data set. So we can straight away taken up that particular data set into a particular variable. So when the import function ensures that here we will be straight away able to load the data set. So that particular data set will be stored in the name of iris. So here we are considering the features as input and target as the output as usual. So we'll be able to do that. So we are going to consider two components as part of this principal component analysis. So as it was mentioned earlier that we can have as many number of components like 2, 3, 4, 5. So whatever the numbers that are required for us, we will be able to consider that, and we will be able to apply to it in order to derive the results. So principal component analysis is basically a very interesting algorithm. So it works with the eigenvalues and eigenvectors for the problem solving. Even students can easily understand the numerical working principle. So those who are interested can spend time on how exactly this particular approach works. So this is how we are applying the principal component analysis through our approach. So here we will be able to see to that how the transformed data with respect to the input data, whatever we are having. So once it is being formed, we will not be calling it as different kinds of inputs like sepal width or sepal length or something like that. Once we are going to apply that, we will be calling it as principal component 1 and principal component 2. So similar like a clustering. So here also we will be able to see how the principal components are being calculated and how it is being probably located in the visualized manner. Here we will be able to see it. So this is the PCA of the iris data set that we are considering with respect to that. So just to give some kind of value addition to whatever we have discussed as part of different machine learning algorithms, so we will be able to cover. So that's how this k-means clustering algorithm as well as principal component analysis is also added as part of this. So with this, we have covered 11 different approaches as part of today's discussion. So support vector machine, simple linear regression, multiple linear regression, logistic regression, polynomial regression, name-based classifier, decision tree classifier, decision tree regressor, k-means clustering, as well as principal component analysis. So all these coding also we have seen with appropriate example. So through our example, so we have generated data for few algorithms. We have used already downloaded data set for few algorithms, and for the last two algorithms we have used the already available data set from the Google Colab itself for utilizing this. So it will be very comfortable for us to use any kind of data. So when we are in a position to present it to students, so we will be able to use all these kinds of steps. When we are in a position to use it for the research purpose, for research paper writing and all, then appropriately we have to handle it different kinds of data. And I hope in the upcoming sessions you will be able to get through hands-on session on the complete uh, implementation exercise on a research paper writing perspective as well, from the data set preparation, how we will be able to build the model optimization. Everything will be covered in the upcoming session for the benefit of larger audiences, especially for the research scholars who are looking for the things. So these kind of exercises we will be able to utilize for giving glimpses to our students, especially those who are learning the course called machine learning. For them, it will be very helpful for them to have a kind of hands-on experience, or during our laboratory sessions, we can train them with the help of these kind of piece of codes, which will give us a complete idea about how to work with the different kinds of algorithms that we will be able to do it. So with that, I will just wind up my session, and so if you have any doubts, I will be available to clarify your doubts. Or else if you have anything to clarify in future also, so you can reach me at my mail ID. So you can reach me in my mail ID also. So if you are getting any doubts or if you need any clarification in any of this particular regard with respect to the topics which are being discussed. So if you don't have anything to clarify, let me wind up my session with this. Thank you very much. Once again, my sincere thanks to the organizers for giving me an opportunity to give a presentation with respect to machine learning and machine learning related algorithms, and most importantly, the hands-on session on different algorithms. Thank you very much.
Thank you so much, sir, for your wonderful session on the hands-on of machine learning techniques. Now, I would request everybody to get back into the meeting at 2:45 for the next session. Good afternoon, everyone. Welcome back. Now we are stepping into the lecture 5, which is about AI in data science and big data. It will be taken up by Dr. Sitanath Biswas sir. So let us know about him. Dr. Sitanath Biswas is a distinguished academician and researcher with over 20 years of experience in the fields of education and cutting-edge research. With an illustrious career marked by innovation and excellence, Dr. Biswas has authored more than 20 research papers in reputed international conferences and journals, contributing significantly to advancements in technology and science. Additionally, he holds 20 technology patents reflecting his commitment to innovation and problem solving. As a former research fellow at Microsoft Research India and the Indian Academy of Science, Dr. Biswas gained extensive expertise in natural language processing, artificial intelligence, and machine learning, which remain his core areas of interest and research focus. His work spans theoretical advancements and practical applications in these domains, driving impactful solutions in academia and industry. Currently, Dr. Siddhanath Biswas serves as the head of Department of CSE AI/ML and CST at JIS College of Engineering. Under his leadership, the department has excelled in fostering innovation, research, and student success, aligning academic pursuits with the latest industry demands. Dr. Biswas continues to inspire the next generation of technologists and researchers, contributing meaningfully to the technological and educational landscape. We welcome you, sir, and I'm handovering the session to you.
Yeah, thank you so much for the nice introduction. So good afternoon, all. At the outset, I would like to extend my sincere thanks for to the organizing team of the FDP called AI for Future. I welcome you all to my session, and I hope that you will like the session where we are going to discuss about certain topic because my topic is given into two different domains. So let me first open my presentation, share it with you, then we will start discussion. Thank you so much. I hope my screen is visible to all.
Yes, sir.
Yes,
Yes.
sir.
Oh, thank you so much. Is it perfect now?
Yes, sir.
Okay, thank you. So basically, in today's session, I'll be talking about the role of AI in data science and big data. So as you know that data science is different and big data is different. So we will try to mix them up, and we will explore that how both of them can be a very powerful technology and tool to create a world of opportunities. So we will start with the first we will start with the big data. Then we will move to the data science part, and I have created a very small code snippet where I will tell you, guide you from a step-by-step process how to create a machine learning model, including data visualization. I believe that it's a post-lunch session and everyone is feeling a bit drowsy. So if you have any questions or anything, you can interrupt me, and we can indulge into discussions. So I request all of you to don't get sleepy, and let me start the presentation. So basically, I'll be covering the introduction about the big data. We'll explain what big data is. We'll talk about the different characteristics. We will also talk about the storing, selecting, and processing of big data. And of course, we need to know why we are talking about big data, how it is different than other data. We'll discuss about the different sources for big data, from where actually the big data is getting bigger and bigger every day. We'll also discuss about the various tools we use in big data, like Hadoop, you must be knowing. And we'll talk about the different applications of big data. Of course, as we are dealing with the big data, which is big in nature, so there must be some risk, and we'll also discuss about mitigating those risks. We'll talk about the various benefits of using big data, and we will also discuss about that how it impacts, the big data impacts on the IT, information technology. And we'll also talk about the future of big data. Then once it is over, we will talk about the data science, and then we will discuss about the code which I have created for you, which will give you a very short glimpse about how to create your first data science model by using big data. So if we start, start the presentation, we must talk about the AI. I believe someone is talking at background. If you can mute yourself, would be better, if you don't mind. Yeah. Am I audible to you? Just give me a kind feedback. Am I audible to all of you? Am I audible to all of you?
Yes, yes.
Okay. Sounds good. So let us start with the artificial intelligence and big data. So basically, artificial intelligence is nothing but when we try to mimic ourselves, we want to develop something which act and behave like us, right? Which has got some learning power, reasoning ability, and problem solving ability, right? And when we talk about the big data is nothing but it comprises of the various data, right? Various data collected from various sources, and we store it somewhere, and then it is called the big data. And in big data, we use a lot of advanced tools, technologies for the processing purpose, storage purpose, and then analysis purpose. And when I talk about this analysis purpose, then the role of AI, the role of machine learning, and the advanced technologies come into picture. And this is how we create a relationship between AI and big data. And later on, we will connect it with the data science. So basically, AI utilizes big data as it is the data is bigger in size. And as we know that AI and the machine learning, deep learning model requires huge amount of data to train itself so that it predict further. It requires a huge amount of data, and big data is the foundation for such machine learning and deep learning model. Or otherwise, we can say that we can employ the different AI mechanism, tools, and technologies, machine learnings on big data to find out some useful patterns, and we can create the data-driven decisions to take our business to the next level. So let us start with the big data. And as you know that we all are dealing with the big data nowadays. We all are the contributor to the big data. If we talk about the Facebook, Instagram, LinkedIn, the Google search engine, whatever we talk about the big data. And in each and every way, we are contributing to the big data and making it bigger and bigger every day. And that's why we call this that the big data is the one of the state-of-the-art technology and data source for the 21st century. And companies like Google, eBay, LinkedIn, Facebook, if we look into their past, when they were a startup, they started using big data very massively, from 1980s, when we started with the concept of big data. And as like the other technologies, like the emerging technologies, big data also, brought a lot of innovations, lot of cost reductions. When we talk about the data storage, when we talk about the data analysis, it reduces the cost in a very big way. And it also helped us to perform complex computing tasks in a very shorter time. So when we talk about big data is basically, it's not a big data. The data is small as, a variable, as small as a constant we write in a program. It can be a name of a person. It can be a number. It can be a age, date of birth of a person, but the bigger in size. Data is small, but contributing to a larger data set, larger database, and that's why it refers as big data. And as the data is bigger, we requires a lot of techniques, tool, and architecture to maintain it efficiently, to retrieve the information, to draw useful patterns. We require tools, technologies, and different architectures. So basically, the aim of big data is to solve new problems or old problems in a better way. So when we talk about big data, we talk about 3 V's. So the first V is the volume, the second V is the velocity, and third V is the variety. So what is volume? Because as I told you that big data is big in nature, so we must talk about the data quantity. And the data quantity started with MB, GB, TB, and now petabytes. Now, when we talk about velocity, it's very important that when we talk about data, we need to retrieve the data as fast as we can. So there comes the velocity. And variety indicates that when we talk about big data, it comprises of many different types of data. Can be a text data, can be audio, can be video, anything. So big data comprises of various kinds of data, structured, unstructured, semi-structured, and all comes under big data. That's why we are concerned about the variety. Now look into the evolution of big data. We know that it started from early 1980s until today, and we have seen the evolution when we first encountered when I was doing my engineering. I just started my engineering. I first came to know about SQL Server when it got released in around 2000 years, when I was in first year. So the SQL Server came into the picture for the evaluation purpose of big data. Then in 2005, Hadoop came into the picture. Then in 2010, companies like Microsoft, Amazon, Google introduces that the low-cost databases, and they started the concept called computing on cloud. So instead of having doing computations on your local computer, the company started doing computation on cloud, and we got a lot of benefits after that, like your Gmail, we got Facebook, we got WhatsApp, and many more applications. And from 2015 to 18, if we look, was the biggest era when companies like, again, Microsoft, Amazon, Google, they started with the new technologies that allow us to do the data analysis. Okay, and of course the data analysis on your local computer or on their on remote servers using clouds. So this is how the evolution takes place for the big data. So let us come for the first V, that's called volume. So in 2000, when it started, the concept of your big data started, we used to have 10 gigabytes of storage typically, for example. And imagine today the Facebook ingests 500 terabytes of new data every day. So imagine that how the big data concept is evolving, and in next 20 years, big data will be prominent in the field of IT and allied areas. And imagine that for an example, imagine a Boeing 737, sorry, will generate approximately 240 terabytes of flight data during a single flight across the US. So imagine if a flight is traveling from one place to another place of let's say of 4 hours of journey, and creating 240 terabytes of data, like how it travels, what are the different conditions, wind conditions and other conditions. So imagine that how we are contributing to data, big data, and the volume of big data is getting increased day by day. And there comes a lot of challenges that we will discuss later on. And now the biggest challenge for the big data is that after when we introduce the smartphone, and we all know that how we use smartphone and how we create the data and how companies consume those datas, keep the backup of those datas, and how different sensors in today's era, in the era of IoT, Internet of Things, how the sensors are contributing the data. Now it is not about a data generated in a day. Now we are talking about a data generated in second, and billions of new data are getting generated from the sensors, from our mobile. For example, where we go, the Google Map keeps all information. What are the pictures we click? That pictures getting stored on your Google Drive or your iCloud. And imagine that the kind amount of information we are generating as a human being, a person is generating, and imagine that the entire world is contributing to big data each and every second, each and every day, and 365 days in a year. So now comes to the second character of big data, called velocity. So if we talk about velocity, a very simple example will help you to understand. Like, let's say if you search something on your computer system or laptop or your phone, like if you want to purchase a particular, let's say for example, a laptop, and you search on Google. After that, you can see that the different vendors are showing their advertisement on your phone, on your laptop, if you are connected with internet, and on your desktop as well. So imagine that you search something, and immediately those search results went to the different vendors. And imagine that how actually the informations are getting collected and stored and then distributed among different stakeholders. So clickstream and ad impressions, if we take for example, can capture behavior at millions of events per second. Imagine that there are billions of people using Google and searching an information, and imagine that clickstreams and impressions, how they are collecting the information, storing it. So that's called the velocity. That's called it takes just a few seconds to capture your information, store it, and then transmitting it to the different vendors. Coming to the another example, stock trading algorithm. You know that stock trading is a kind of thing that the result change in every seconds, even some microseconds also. If those who are into trading, they can understand. So imagine that if we have developed some stock trading algorithms, and they go through the market trends and generate lot of data within microseconds, milliseconds, and those data are even collected and stored on the big data. So the kind of there comes the velocity, means the speed. Then comes to the rest of the things like machine-to-machine process exchange data, sensors to machines, and so on. Then the third V and the last V is called variety. Now, big data is not just a number, date, strings, or it's not a database that when we go to a shop, purchase something. For example, we go to Pantaloons and purchase a cloth for us, and they generate a bill. They take your phone numbers, store it, retrieve your few data like your name, address, and your phone number as primary key, and generate the bill. It's not like that. The big data can comprise can have audio, video, unstructured, semi-structured, log files generated by websites, social media, photographs, 3D data, geospatial data, anything that calls a variety. When we started with databases, we were only interested for the transactional data, which consists of some worker kind of name and your mobile number, your address. But now the horizon is expanded, and we are generating any kind of data, and that data is a part of your big data. So so the next big question is, when we talk about the huge amount of data like generated from different sensors, mobiles, your computer system, or your other sources, then the question comes on our mind that how to store the data. So that's very important. So before storing the data, you need to analyze the data characteristics. Then only you can select the data sources, the data storage. So first is you need to analyze the data characteristics. So first we need to look into the selection of data sources for analysis. Next is eliminating redundant data, because all the data may not be important to us. So we need to also eliminate redundant data. Then while storing, we need to understand that this big data is not a structured data. So we need to somehow establish the concept of NoSQL instead of SQL, because the data can be anything. So that NoSQL concept we need to establish. And we use different data model like key value, graph, document, and all that. Now, selecting big data stores. So choosing the right data stores depends on the data characteristics, and it completely depends on the kind of data you are dealing. And even when we talk about the data can be a polyglot nature, means it can be multilingual also. So we need to consider these aspects while store. Yes.
अरे तुमच्या इनॉग्रेशन कमिटी मधले एखाद्या स्टुडंटला पाठवा.
Hello.
इन्व्हिटेशन जे केलेत ना.
Okay, there was some background noise. I'm sorry. We'll continue. So when we have the data, am I audible to all of you, right? Can I get some answer?
Yeah, audible, sir.
Okay. Thank you. So now we have seen that how to select the data stores. Now the processing data. The processing data is important because you need to store it effectively, so that again you can retrieve it for any other purposes. So basically the general purpose processing concept started with the Hadoop, a very old concept. It came around 2005, and while we go for subdividing the data, we use the concept called MapReduce, and these are the prominent two technologies we basically use when we talk about the big data. Now we'll discuss about the structure of that big data. As I was repeatedly telling you about the varieties of data, so data can be structured data, like your transactional data, like your it can be data like college management system, school management system, or an inventory shop. You get almost all structured data. Then comes your semi-structured data. Semi-structured data basically comes from your Wikipedia or kind of educational sites, they all deal with the semi-structured data. Then comes unstructured data. Unstructured data are the data which actually every day we are using, we are generating from our mobiles. It can be video data, it can be audio data, it can be hashtags, it can be a Facebook post, it can be LinkedIn post, very unstructured in nature. We do not follow any structure for that. So when we talk about that structured data, basically it is a traditional data warehousing kind of concept. When we talk about semi-structured data, we apply text mining. When we talk about unstructured data, it's a kind of video surveillance, and all that. So now the next big question is, why big data? So as I have already explained, that big data is the key player in this era. We are in 21st centuries, and we want more and more analysis. We want more and more predictions, future predictions. So there comes the big data. So that's why we are all encouraging big data to be to grow, and that's why we talk about increase of storage capacities, because it requires of terabytes of space. So we talk about the increase of storage capacities as well as maintaining that storage properly. Then we talk about the increase of processing power, because we can't wait for our data. If we have to wait, if we query something on Google, and if we need to wait for 1 minute, probably nobody is going to use Google anymore. So processing power is extremely important when we deal with big data, because the data need to be fetched very fast, and the availability of the data, that's very important. Once you made a query, you want that data to be available. And of course, it's up to you that kind of data you are looking for. And that I have already discussed about the different kinds of data in big data we have. Okay, so now this picture depicts everything. What I want to establish is that like in 2003, just looking at the picture, 2003 the world population was 6.3 billion, and the connected devices were 500 million. Now today in 2020, this slide is a bit old, I'm sorry for that. In 2020, we had 7.6 billion world population, whereas the connected devices are 50 billions, means much higher, where it was 0.08 at a certain point of time in 2003. Now in 2020, it was more than 50 million, and in 2024, it is more than 75 billion connected devices. And all those connected devices are contributing to the growth of the big data. And as per the prediction of different surveys conducted by the reputed organizations, that the connected devices per person would be more than 10 after 5 years. And as you can see in my slide, that IBM claims 90% of today's stored data was generated in just last couple of years. So imagine that how fast we are contributing to the growth of the big data. So the next is how is big data different? So big data is different than any other data like transactional data and any other data, because it accommodates many different types of data. The data can be automatically generated by a machine. We can see there are a lot of sensors. We can see there are a lot of cameras installed on traffics. They can take the videos and can be a part of the big data, and different sensors we get. For example, weather forecasting systems, we use a lot of sensors, and those sensors are generating huge amount of data every minute. And And here, that's why the big data is different, because it automatically generated, it can be automatically generated by the data, can be automatically generated by the machine. And the data can be a completely new source of data called the internet, where many different social medias and other sites are continuously contributing to the big data. So here is a small glimpse of the different sources of big data. We are the users. There are a lot of applications. There are a lot of systems. There are a lot of sensors, and they contribute to the big data. So let us talk about the data generation points. As I have already discussed that we have mobile devices, and now people having multiple mobile devices with us. We have laptops, we have computer systems, each and everything, every devices are contributing to the big data. We have different other devices, microphones, readers, scanners, science facilities. We have a lot of softwares, we have programs. Not those programs and softwares are dealing with the data. We also generate a lot of logs from those programs and software, huge amount of logs and logs from those programs and software. I have already discussed about the social medias, then cameras and sensors. These are all contributing to the data and called the data points. Now coming to the analytics part, where my topic is converging that AI, data analysis, big data. So data analytics now become the buzzword, and people are doing a lot of research nowadays on data analytics. And to be very honest, we are generating a lot of analytics nowadays. If you look into the online businesses like Amazon, like Make My Trip, like Alibaba, they all are actually dependent on data analytics, and their businesses, if they are able to grow their businesses, are definitely based on the data analytics, because they generate business through the data analytics only. So what data analytics is that, when we examine large amount of data and we generate appropriate patterns, or we make decisions out of those analytics, is called the data analytics. And for that we need appropriate information, and appropriate information will be generated from the big data itself. And we are interested for hidden patterns, unknown correlations, and thereby we create more business opportunities. And when we talk about better business decision, it must be strategic and operational. And for both of them, big data analytics or the data analytics is contributing a large. I will show you when I will explain you the hands-on, the code. I will show you that how from a data set we are creating the analytics and getting very useful insights. So now we will be talking about the different tools, modern tools we are using nowadays for big data. So first is you must be interested about that where we actually host the processing. The processing is done on definitely the distributed servers, cloud, and one of the biggest vendor is Amazon EC2. And if you are talking about data storage, we believe on Amazon S3, and many more vendors are there. For example, I've given only one. And obviously the storage are distributed storage, because single storage will not be able to accommodate such a big data. So we go for distributed storage. And when we talk about programming model, we talk about the distributed processing, such as MapReduce, one of the oldest and very famous tool we talk about. Then for indexing and storing, we prefer nowadays MongoDB. That is based on your high performance schema free databases, unlike your normal databases. And what performance we perform on these data? We perform analytics and semantic processing, we apply many machine learning, deep learning algorithms. We use natural language processing, and we do certain operations such as sentiment analysis and all that. So if we talk about the applications of big data is now everywhere. I cannot just simply say with this kind of fixed areas. I have given some of the areas here, but if you look into big data nowadays, for each and every business, they all depend on big data, starting from your smarter healthcare. If you're talking about security, if you are talking about traffic control, if you're talking about large manufacturing industries, if you're talking about even Google search or other search engine, if you talk about the trading analytics, telecom sector is hugely applying data analytics. Then sales is, of course, one of the oldest platform where we started using data analytics. Now, as we are dealing with big data, there are certain risks because big data involves various types of data. And when there are various types of data, for example, medical data, for example, data related to insurance, data related to your banking. So risk is always involved, and we need to mitigate that risk in order to protect the data which is private, and people may not be interested to make it open. And for that, we have a lot of self-regulation and legal regulations. Some of the leading technology vendors nowadays, prominent vendors are IBM, EMC, Oracle. They are the leading technology vendors for big data nowadays. And let us talk about how, I'm sorry, just give me a second. Yeah, so how big data is impacting in IT industry, that's a very important thing. So if we talk about big data, we expect that big data will be impacting the entire IT industry in several ways by 2026, including big data market growth. As I was talking about the data growth and the devices per person, and the data, the amount of data we are generating. So the big data market growth is the next big thing, and the global big data market is projected to reach US $512 billion by 2026. And compound annual growth rate CAGR is approximately 30.08% from 2020 to 2023. Now talk about I talked about the market growth. Now talk about the infrastructure market growth. If we talk about the infrastructure market growth, it is approximately US $4.2 billion by 2026. So you can look into how the market is growing, and the opportunities thereby we are creating for the professionals, for the students to be a part of this growing industry. And we have a lot of job opportunities that we will discuss. Now, big data as a service market growth. So big data as a service market growth, we can see that it's quite high than the other, is almost US $62 billion. And it will grow US $62 billion by 2026, and the growth rate is 36.9% from 2019 to 2026. Now, next is data center. Yes, of course, we require data centers because we talked about the data, big data. And India's data center industry is expected to grow by 66% by 2026. And as you know, the population of India is too high, and India is completely indulged into IT industry, and we are the biggest manpower resources to the entire world. And that's why we will be getting a lot of opportunities, and the growth rate is very promising. So here some potential value I have given. You can just go through the slide. we have the manpower, IT professionals, and we have graduates in math, science, we have engineers, and graduates in different other allied areas. But people with data science background is always accepted in the big data industry to be a part of it, whether it comes to maintenance, it comes to storage, it comes to analytics. People from all different segment can contribute. So coming to the different benefits of big data using analytics. So we can see that big data tools can help small business assesses their finance and compare their pricing to complete the global market. Now, a very important thing, if you know, like even nowadays, for example, the educational institutions, small educational institutions, schools, they are heavily relied upon the data analytics and social media. They do small data analytics and use social media to get students, they recruit students. So if we talk about the small business to large business, of course, you can see the business model is growing. And then if we are talking about the analytic part, then big data is contributing to today's landscape in terms of the data safety. It also helps us for fraud detection because you can, if you apply analytics on big data, you can find out anomalies and other things on and easily, and we can improve the efficiency. Risk management is very important. We can increase sales and revenues for the companies. We have strategic business choices, from supply chain to cost optimization. Everywhere big data and analytics is contributing a lot. So if we talk about the future of big data and AI, as I told you that India is rich in population, and India is contributing to IT sector since last few decades. So the future of big data and AI is very strong. And if we talk about the various areas like data-driven decision making, AI/ML automation, if we talk about predictive analytics, we talk about the data literacy, we talk about the data monetization, unified data platforms, cloud technologies, ethical data management, demand for data science roles, and big data engineers, then everywhere we can see the future. So starting from the data-driven decision making, it's a business. From if we go for the automation, developing complex softwares, systems. If we talk about predictive analytics for the business, if we are trying to make people literate about the data, from A to Z, if we can say that the future of big data and AI is quite promising in next 20 to 30 years. So this is what this is all about. We talked about the big data, and now we will move to the data science. That is the second part of my talk. I took approximately 45 minutes, if I'm not wrong. Okay, so I'll try to finish this PPT as early as possible so that we can look into the code which I have prepared for you today for the basic understanding of creating your first data science model. So in this particular talk, we will discuss about the data science and its importance. We will talk about the various data science process. We will talk about the AI and data science, the relation, and we will talk about the prerequisite to become a data scientist. So what is data science? Data science is an interdisciplinary field that uses algorithms, procedures, and process to examine large amount of data in order to uncover hidden patterns, generate insights, and direct decision making. Now again, we are going back and bringing the big data into picture, because for data science we need the big data. where we will be applying this data science and we will be generating the insights and hidden patterns. So we'll talk about the importance of data science. So let's talk about the career opportunity. The rise of data science needs will create, exactly in the last slide I talk about that demand and about India and its contribution to the IT sector, that 11.5 million job openings by 2026 we are expecting, and the prediction is given by US Bureau of Labor Statistics. And by 2026 the data scientist and analyst will become the #1 emerging role in the world, given by World Economic Forum. I collected it from World Economic Forum. And if we talk about the data science and artificial intelligence together, will be the hottest field of 21st century, and will impact us in 2025 and maybe 20 years more. This will be very prominent. So if we talk about the importance of data science, data science helps brands to understand their customer in a much enhanced and empowered manner. So this leads to direct benefit to the companies to generate revenues, because when we deep dive onto the data and find out the useful patterns from that, and understand that what exactly the buying pattern or other important aspect of the customer, then we give much better or tailored products or services to the community. Okay, and this data science can allow brands to communicate their story in such an engaging and powerful manner. Because see, when we deep dive into the data, we, let's say for a company providing a service to their customers since last 10 years, and they got the data of 10 years, and they deep dive into the data and apply analytics and found out that different types of reviews they received from the employees and from the customers, from their employees and other stakeholders, then they can improve themselves. So this is a very important thing for brands to sustain longer in the market and generate their business. And big data is a new field that's, I already told you, constantly growing and contributing to the data science. So if we talk about see again, as like the big data, as it is required everywhere nowadays, it becomes a part of our life. So data science is almost the same, because we have seen from healthcare to finance to e-commerce to retail to transportation to marketing to social media, energy, sport, agriculture, and many more. There is no boundary as such for the data science, and data science is applicable to almost all sectors we are dealing with nowadays. And if we talk about the healthcare, we have predictive analytics for the patient care. And if we talk about finance, fraud detections like credit card fraud detections and all is very prominent. We have we talk about e-commerce, then we have recommendation systems. As the example I have told you, like if you search something on your search engine, you can get customized advertisement on your different social media platform. We have retail, like it really contributes to inventory management and demand forecasting, like for example Pantaloons, Reliance, this company is having their own merchandise stores, and this data science provide them a lot of insights for to forecast their demands. Then coming to transportation, we use it for route optimization, traffic management. And if we talk about the transportation, you can see how Google Map optimize itself, and it all depends on the data. Then we have our customer segmentation and targeted advertisement. You might have seen in Facebook, in Instagram, and in LinkedIn for hiring talents. LinkedIn use targeted advertisement. for school, colleges, you might have seen their customized advertisement. It becomes a regular part of our life. Social media, we do a lot of sentiment analysis and content moderation over there. And energy, there are smart grids and energy optimizations. Nowadays, even data science is largely contributing for the EV, electric vehicle and the battery operations. Then if we talk about sports and agriculture for crop yield prediction, precision farming, then many other fields, the data science, contributing a lot. So we'll move to the next slide. So let us come to how data science work. So for data science, you need to first collect a data set, right? So you need to gather the raw data from various sources, right? That explains the business problem that you want to solve. Then you analyze the data, right? After collecting the data, you analyze the data using various statistical analysis or machine learning approaches. And then you find out the actionable insight. So this is how the data science works. So first you need the data, you analyze the data, and then get the insights. So let us suppose you are solving a problem, and similarly you have to follow the same path for any case study. Let's say, for example, you want to apply data science on a particular field called telemedicine. So first you need the data. You need to collect the data onto the from the field telemedicines. Then you analyze and then generate a lot of insights from there. So in above example, we saw one thing, that machine learning is required for insights. Now coming to AI and data science. Now data science and artificial intelligence are two technologies that are transforming the world. While artificial intelligence powers data science operation, but data science operation is not completely dependent on AI. That we will explain later. Artificial intelligence power data science operation, that's very clear, but data science is not completely dependent on AI. That we will explain in the later slide. But we have to remember that data science requires machine learning algorithms, and that creates the dependency on AI of data science. So let us we will compare the AI and data science. So basically, data science jobs requires the knowledge of machine learning and programming languages like R and Python. They are the most prominent programming language to perform various data operations and other computer expertise. Data science uses more tools apart from AI. This is because data science involves multiple steps to analyze data and generate insights, and statistics is a part of it. Data science models are basically built for statistical insight, whereas AI is generally used to build models that mimic cognition and human understanding. So if we look into today's industry requires both data science and artificial intelligence, because data science will help them make necessary data-driven decision and assesses their performance. There are two aspects, like not only we generate the data-driven decision, we need to also assess the performance in the market, and we need to ensure that the business is growing. But artificial intelligence will help industries work with smarter devices and softwares that will minimize workload and optimize all the processes for improved innovations. So if we look into the broader picture of the concept, so basically artificial intelligence is contributing the bigger circle, and machine learning is a part of it, and deep learning is the subdomain of the entire artificial intelligence. And data, you can see the convergence here. The data science is converging, and data science, as I told you, that data science and AI is different because Data science requires, apart from AI and machine learning, data science requires a lot of mathematics and statistics, visualizations, and EDA, exploratory data analysis, as a part of data science. So this is what the difference. So we'll talk about the prerequisite for data science if you are really interested to be a data scientist. So you must be having the clear concept of computer science. You need to know about the statistics. You need to know about the machine learning and visualization, because once you generate the pattern or useful insights, then you need to show them through the visualization, and visualization helps us to understand it better than any other form of representation. And then we have of course human computer interaction. So the roadmap would be, first, if you would like to be a data scientist, the first and foremost thing is you need to learn the programming language, and commonly used programming languages are Python and R. Python is relatively easy to learn than R, and you need to know the basics of mathematics and statistics, like you need to know the calculation of mean, median, mode, standard deviation, etc. Then you need to know the concept of data visualization, and for example, in Python we use different libraries, inbuilt libraries are there, called Seaborn, Matplotlib, by which you can create beautiful plots, graphs to visualize your data. And of course you need to know the machine learning concepts like linear regression. If it comes as a regression problem, you are working with the time series data, you need to know the linear regression, logistic regression, decision tree, SPMs. There are very standard machine learning algorithms, KNN, random forest, and of course you need to try with a lot of projects building machine learning models using data sets. And there are different platforms are available. If you are lacking with your local computer system which you have, might not be having that much of computing resources, you can try with Kaggle, you can try with Colab. Many other platforms are there you can try with. I personally prefer Kaggle. I have done a lot of coding over there, so I feel that Kaggle is much better than any other. But if you are using Colab, you will be getting Gemini over there, Copilot. You can use Copilot to rectify or correct your code. That's a benefit of using Colab. But I personally prefer Kaggle, because Kaggle is the one of the largest dataset provider, so it's very easy to use the dataset over there. And Kaggle also gives you the GPU time which is quite higher than the Colab. So if we talk about the programming language, I personally prefer Python, but it's up to you that you decide whether you will go for Python or R, because Python or R are the most prominent programming language. And if we talk about Python, 40% of the people participated in a survey by O'Reilly, has got 40% people are really like Python as a programming language for doing data science programs, because Python has got many inbuilt libraries like Panda, NumPy, and many other Seaborn, Matplotlib, PyTorch, Panda, Scikit-learn. Lot of libraries are there which are very useful for developing data science projects. And Python is a choice, or you can go for R programming. If you are active on LinkedIn, you might have seen that 30% of the job posted over LinkedIn or any other platform, they specify R is the mandatory programming language that the data scientist must know. But to be very honest, becoming master in R programming requires a lot of efforts. And if we look into the choice, 43% of the data scientists prefer R over Python. But R also having its own many different libraries, inbuilt libraries, which are very useful for data analysis purpose. Apart from that, you need to know the mathematics and statistics, because ML is a part of the data science. But apart from that, you need to know the underlying mathematics and statistics, that how the data is getting, how we are creating, developing the model, and how we are evaluating them. How do we do feature transformation? How you will be reducing the dimension for better accuracy, how we will be doing feature engineering. Then required data pre-processing requires heavy mathematics and statistics operations. So it's really important to know the mathematics, and of course linear algebra is a very important part of that. As I told you about the data visualization, data visualization is a prerequisite for any data scientist. It gives you clear understanding, a visual understanding about the pattern or the insights you have created in form of graphs and charts. And these graphs and charts are very easy to interpret. And as a data scientist, you must be understanding the data and the pattern and all those things. But when you are going to the other stakeholders, like the manager of the company or the CEO of the company, or maybe your client, they may not be able to understand the data, numeric data and other data. But the graphs and charts would be much preferred to them to understand. And for data visualizations, there are multiple components. The data component is the first step to visualize the data. Then we have geometric component that that helps you to decide what kind of graph or plot you need. Like you need a histogram, you need bar plots, you need scatter plot or line graphs or bar graphs, anything. Then next is mapping component. In this component, you decide what variable you should use as independent variable and dependent variable. In program, we talk about X variable and Y variable. And then we talk about the labeling the component. When you are generating bars and generating bar graphs or other charts, you need to understand about the different levels. You need to work with the legends, title, and font size. It's quite related to design. And we need to go and we need another one is called a scale component, that you decide what kind of scale you want, that log scale, linear scale, etc. You can see it in my code. Later on I'll be discussing about. We'll explain each and everything about this data component and geometric component. We'll discuss. So coming to machine learning and artificial intelligence, I've already explained that machine learning is a part of artificial intelligence, and machine learning helps in analyzing large amount of data using algorithms. Using machine learning, major parts of the data scientist jobs can be automated. And so there are certain tools you must be interested to know that we use for data analytics is called Apache Spark, Apache Hadoop, Python, and R. One of the most preferred, I preferred is Python. Now coming to the challenges, because AI is going to be the superpower, and big data will be making it as a superpower. So we need to inspect about the various challenges, starting from the data quality, because when we are deep diving into the data, we need to ensure that data is correct and complete in nature, so that we can create better AI models. And we must be very cautious about the privacy, because protecting sensitive data is crucial. Otherwise it can be used for some other wrong purposes. So when we are dealing with the data, we need to look into the privacy of the people contributed in the data. And the most important technology we are now experiencing today is called explainable AI. It's not about that how AI model creates or generates patterns for you, made decisions. That's not important, but important is that how they do it, right? That requires explainability, and nowadays we have started working on explainable AI is a different part of study. You can look into some of my works which are available on Kaggle. Explainable AI, very interesting work, where the machine explain you, your model explain you that how it has arrived in such decisions, so with a proper explanation. Then comes to ethical consideration, as all of you know that when we talk about AI and talk about artificial intelligent machine, we must think about the ethical part of it. So this very important aspect. So if now I'll conclude, and I'll say that the AI and big data are the regulate creating the next generation for the data analysis and insights, and AI and big data together are offering powerful solution for wide range of industries, including all industries nowadays. So understanding the foundation techniques and applications of AI is very essential for the future data-driven decision making. So I will stop here my presentation, and we'll look into the code that I have prepared for you. So if you want to follow me, you can follow me on Kaggle. If you are already familiar with the Kaggle, you can start working with me. We can work together. Or if you're not sure about it, you can ask me. I'll guide you step by step. And also you can do it on your laptop. If you are on laptop or computer system, you can just follow me. We have done a very small program for you to give you some hands-on thing. Just give me a few minutes to open my Kaggle account, and we'll demonstrate you. By the time, if you have any question, you can ask me, or else we'll look into the code. So if you are familiar with Kaggle, you can just type on, you can type kaggle.com, kaggle.com, okay, or you can just follow my code. So writing the code will be much time taking, so I have already created the code. I'll show you the step-by-step process. So let me know whether my screen is visible to you. Is it visible now?
Yes, sir.
Yes, sir.
That Kaggle page is visible now? FDP on AI for future?
Yes, sir.
Oh, so this is the Kaggle interface, right? So what we'll do is that I have already created this code, and I'll explain each and everything. And you do not have to, write down or do anything with the code, because code is publicly available on Kaggle. You can just go to this link, and you can later on work on this code. And if you want to simultaneously work with me, you can do it. So actually what happened, to build the code, I had to initially had to add the data set. So if you are familiar with adding data set on Kaggle, it's all right. Otherwise, I will create another book. I will create another notebook. It's a kind of Jupyter notebook, right? And I will show how to create and how to add data set over Kaggle. So let me change the name here. Again, I'm giving FDP for the understanding purpose. Okay, so FDP. KG Reddy. Okay. Right. So this is what you can see the interface. Now I would add a data set over here. Here you can see that notebook and add input. Can you see my screen properly?
Yes, sir.
Okay, okay. So here you click add input, and it is showing a lot of options like all. If you have your own existing work, a data set or different models. So I'll be choosing one data set that I have already fixed it. It's a Airbnb listing and reviews data set created by Ahmed Bhatt 3 years ago. It's a time series data and text data and in CSV format, right? And it is having around, I believe, I'll show you. It's having 250,000 plus listing in 10 major cities, including information about host, pricing, location, room type, along with over 5 million historical reviews. So this is time series data, you can say, and here we have the different data like listing, like the way we list our hotels listings. We have listing data dictionary. We have separate reviews, CSV file, and reviews data dictionary. So this is what the data is, and the overview of the data is given here. So we'll start work with this particular data set. So instead of download, so what I'll do is that I will add this data set. Just a moment. Yeah, I will add this. So now you can see this data set has been added here. You can see here Airbnb listing reviews, right? Is that clear? So you can see Airbnb listing reviews is added. Now I'll go to my earlier page where I have already created the platform. We'll go to that. So I told you how to add data set on Kaggle. Okay. So I'll go for edit. So this is the code snippet. So I'll go for run. So if I run, I have already added the data set. So this will essentially add the data set on this editor and will show me the path. So these are the path of the data set. We have 4 paths, as I've told you, that we have listings, we have reviews data dictionary, and we have listing data dictionary, right? So I have loaded the data set perfectly, and the dataset path is given. Now I will try to explore the dataset. Okay, you can follow me. Explore the dataset. So to explore the dataset, I need to import Panda. It's a library, inbuilt library, and I have given the dataset path. Okay, and as the dataset path, some of the entries were in Latin, so I had to specifically written Latin here. Otherwise, it is English. It is not necessary. So the dataset, when exploring the dataset, I found that the dataset has got some Latin reviews. So that was creating problem to load the dataset. So I have done the encoding Latin for that. And now I will be displaying the dataset information, okay, by printing some of the information from the dataset. So if I run this, I'm exploring the dataset. So here it is showing some warning. You can leave it because some of the libraries may be old. Now you can see that the data set is showing here the column and the attributes, right? So here it is showing 2,79,712 entries started from 0. We have total 33 columns. So this is called the data visualization. So I'm able to see the data, the memory uses over here, and the different listing, the different view of the data, listing ID and name, and host ID is also given. Here we can see host scenes, then host location, host response time, and see, you can see there are certain field called none, right? So this is a problem with the data set. In the pre-processing part, I will explain you how to remove this none, because they will be creating a lot of issues while doing the data analysis. So these are all what is, the data set I'm able to visualize now. Okay, great. Now I'll come to pre-processing. Okay, so like you have seen in this code, there are certain things like none is not a valid entry in the data set, so we will have to remove it. Then we have few blank in the data set. No entries were made, so we call it as missing values. So that we will now handle. So here I'm handling the missing values. So first I will print the missing values in the listing, and we will search by using isNull function, and we will also see in the listing and as well as in the reviews, and we will use the same function called isNull and sum, and then I will fill or drop the missing values. So in case none, we will be just drop the values we don't want, and for any kind of missing values, we will try to fill the value, because otherwise it will be an error for us. So that is what I'm doing, and this is what I got. The missing values in listing ID, somewhere it is missing, it is showing 0. Host ID, somewhere it is 0. So similarly accommodates 0. So missing values in reviews is listing ID, we have got 0. Reviews IDs, we have got 0. Date, reviewers ID. Okay, so now we have understood the data and cleaned it. Sorry, we dealt with the missing values. I'm sorry, missing values. Then coming to cleaning. So I'll be cleaning. So data cleaning is done. What type of cleaning I have done? Because the price range and other columns were having dollar, and dollar is not comes under numeric, so we wanted to remove the dollar, commas, etc. So from the price, we have removed dollar, and we make it as a normal numeric value in order to process it perfectly. Then I am doing the feature engineering. So feature engineering is done because I would like to extract some, I would like to do the analysis or depending on certain parameters. So I have done some feature engineering. Now feature engineering is completely on you, the kind of problem you are developing. For me, I have created a decision tree for you, because decision tree is one of the most simple thing, so that you can understand, and later on you can go for some more advanced machine learning models. So I did feature engineering for decision tree, and I would like to print the summary statistics. So by using describe method function, I will be showing the data after pre-processing and cleaning. Now you can see that no table is having none, 0, dollar, nothing, right? Then I will be doing some group analysis. So here I wanted to see the average price by room. And this is my perception. You can do any other operations as you wish. So I wanted to see average price by room type. So room type can be hotel, room type can be private room type can be poolside room type can be shared, or room type can be entire place I would like to hire. So what I did is I did average price by room type. So, and that is what it is getting, shown here. Average price by room type. Room type is entire palace, and it is showing its price accordingly. $673 something point something dollar, $800 for hotel room. Private room, it is approximately 462. Like Airbnb is having private room as well. You can stay there. And shared room, it is $580. So we'll go for now we'll go for visualization, right? So for visualization, as I told you that we use matplotlib and Seaborn. So here I have imported both the libraries to do some visualization task over here. And first I will be creating bar plot, okay, based on the visualizing room types and prices. For that I will be creating So I have created a bar plot. Very simple. Just plt.title. Then you create the X level. As I have told you earlier in my slide, X level, conditional and unconditional. Y level. Y level we have taken as average price. X level we have taken as room type. And then we are showing the details. So 800 is for the hotel room. 600 something was for the entire palace. The same data here I have generated, you can see in this data, and the bar graph is showing the same visualization instead of this text data. So I have created a simple bar graph. Then I would like to see the distribution of prices. So here I have taken the title as price distribution, where X level is price and Y level is frequency. Yeah, this is price distribution graph. Then we will see the reviews over time. Okay. Just a moment, a bit got slower. I think this is having some problem. It's not getting loaded. Okay. So now we will look into the, I would like to, I wanted to show you the reviews over time, but I could not show, I don't know whether this code is, why this code is not working. Okay. Now we will create the decision tree first. So basically, creating your first machine learning model is depend on that how you choose a problem and how is your solutions, right? So here we will predict a listing price range depending on starting from low, medium and high. So this is my problem and I would like a solution like this, and we will use the features called room type, number of reviews and location from Airbnb dataset, right? So here I have taken the decision tree, and the decision tree will be working on information gain and entropy and Gini index. So let us, no, I believe there is some problem. Let me again reload this page. Just give me a second. Yeah, just give me a second. The session is getting started. So we got this right. Yeah, we have seen all this. This group analysis. Okay. This bar graph is working perfectly. Yeah, price distribution was done. Yeah, that's working. So reviews over time. So you can see 2008 there was no review. In 2009 no. Till 2011 there was no review. 2011 12 we got a review. 2013 it got increased. 2019 it got high, and the data is actually collected in 2021. This data set was created in 2021, so we have got the last data of 2021. So this is what you can see, the reviews per year, and year wise the legends have been created, right? So now we are going for creating our first machine learning model decision tree. And as you know, the decision tree is a machine learning and it's versatile, interpretable algorithm used for predictive modeling. Okay. So it basically use three things: information gain and entropy and Gini index. And then it creates a tree kind of structure. I don't know why it is not working. Just give me a second. Just 1 second. I believe that there is some problem with the server. Yeah. So you can see that I'm again loading and exploring the data set. And here we have we are importing pandas library. And again, I have given the data set path for the data analysis purpose. We are exploring the different columns in the data set. And we would like to ensure that the data set is in proper format. So we are just looking into few rows of the data set. That is what is showing over here. Columns in the data set is index. And under that we have listing ID, name, host ID, host scenes, host location, host response time, host response rate, host acceptance, and so on. Okay, and we are again showing the few rows. And now again you can see that this none and $0 will appear, because again we are starting from the decision tree from the scratch. So again we need to do all those again. So now we are cleaning the data set. This is for defining the required column price. We are taking room type, number of reviews per month, and here we are creating the listing. And we have cleaned the data set where we do not have any null, none, or dollar. Now here we have done the feature engineering. We want the price range to be the key thing, and based on the price range, price range is defined as low, medium, and high. And based on that, we are selecting the features called room type, number of reviews per month. Based on these two, our decision tree will show you the different prospect of the data. So it is showing the sample features. So as you know that for any machine learning purpose, you need to split the data set. So we have splitted the data set into training as test data set. And you can see the division is given here: training data set and test data set, mostly around 80 to 20%. 80% is the training and 20% is the. So here you get 2,23,769 out of 27 lakhs. 2,70,000 approximately data. It's around 80%, and 55,943, which is got around 20% of the data. Then we are cleaning the data, and now that it is showing the exact data after cleaning and removing the unnecessary data. Now here we are creating the decision tree, and for that we are importing one library called sklearn scikit-learn, and from scikit-learn we are importing decision tree classifier, where the decision tree classifier algorithm is implemented, and we are taking xtrain and ytrain from where the output will be mapped and given. So here it is showing model training complete. We have executed, and model training is done. Then I'm evaluating the model to see its performance, right? So the prediction of the model depends on the criteria. It's called F score that I have defined over here, F accuracy, and you can see the accuracy. So this is only for educational purpose. We have not done any other, optimization and all that. So that's why you don't go for the precision recall and F score, because this is for just to educate you and build your fast machine learning model. There are many things to do, including proper way of pre-processing the data, your model tuning. There are a lot of aspects, and you get the better F score. So this is for just for showing you a demonstration purpose. So don't get scared out of these F score values. So we have a lot of more things to improve the decision tree model. We need to do a lot of mining into the data, and then average accuracy we can increase up to more than 14. It's around 40% accuracy it is showing. Don't get scared. This is for just for to show you, to educate you. That's it. So we can improve it later on. So this is what the decision tree is looking like. It is giving you the Gini index over here. Okay, and the samples it has taken, it has chosen random samples, and based on that it is calculating the Gini score. And subsequently this is the parent node and the child node, and for each child node the Gini index is different. By calculate, they are taking the random values from each and every node, and out of the random values they are calculating the Gini. And then after that we are generating the graphs, that's price distribution. Okay, then the room type distribution, it's a bar plot, you can see. Then we have created a heat map. So heat map is a graphical representation of data that uses colors to show the intensity of a variable or relationship. So this is called a correlation heat map. Okay, and you can see the legends over here, listing ID, host response rate, host acceptance rate, and all these are represented in the correlation heat map. You can just go through it. And based on this, the accuracy is given, the final average accuracy is given for best and for different classes we have. Then we have used, you have created a scatter. Am I audible to all of you?
Yes, sir.
Okay. I got that. I thought that I got disconnected. So okay. So here we have created a scatter plot, and the scatter plot shows you, gives you the representation of price versus number of reviews, and you can see the number of reviews are more when the price is a bit less compared to the higher prices. the higher prices rooms normally people do not take, and mostly you can see these reviews are mostly till 20,000 2 lakhs in between, from 0 to 2 lakhs. So we have also created a box plot. So in box plot you can see that we have taken price distribution by room type. So the price distribution by room type, and here it is showing.
Sir.
Hello.
Yes.
Excuse me, sir.
Yes.
It is not visible the screen.
Screen is not visible.
Yes, sir.
Okay. Just a moment. Is it visible now?
Yes, sir. Now visible.
Okay. Thank you. So this is a scatter plot. Here we are showing price distribution by room type. Okay. So if you look into the hotel room, you see that the price distribution is much lower. And if you talk about the shared room, because there is a tendency among people to go for hotel room and shared room instead of private room and entire place, because that is very costly for a person to take. So now we have created another scatter plot, number of reviews versus reviews per month. So that you can see is very less, because if we Airbnb is used by billions of people around the world. But if we look into the reviews, number of reviews versus reviews per month, may not be, people have given much reviews for a particular month. So you can see only one dot over here. And then now we will predict the top most 10 expensive listing, and that we'll be doing by bar plot. Okay, so I'm just extracting 10 most expensive listing. Okay, and the 10 most expensive is went up to 6 lakhs to here the different name of the different accommodations. Some of the accommodation name is not visible because that is written in Latin, so you cannot read it. But this is from Brazil. This is from okay. So they are basically representing the name of the hotel, and the prices are given here from 1 lakh to 6 lakh. And you can see the most expensive listing. This hotel is charging much higher price than the next 9 hotels, and this beyond is charging the less compared to other other hotels. Then we have created another bar plot, average price per room type. So based on the different room type, how much Airbnb is charging. Okay, so average price we have given. If you are taking the entire place, it is charging approximately $670. And if you are taking the hotel room is quite higher. If you are taking private room, is bit less. And if you are going for share room, bit costly, because there are a lot of parameters while sharing the room. So this is what the data visualization, data analysis, and your first machine learning model, including data pre-processing, data visualization. I hope that this code is useful, and this is made public. If you want, you can just go through the code at any point of time, and it will help you to build your machine learning model on Kaggle using any data set. I have already demonstrated you that how you can actually add data set and start working on Kaggle. And Kaggle has got a lot of many features, like I'll show you many features. Like here, if you see that it is showing the output generated will be showing here. If you click over here, it will show you the. Okay, we have not created any CSV file, that's why it's not showing. So there are a lot of many other features, like session option. If you want, you can turn on your GPUs. They are providing 3 GPUs. GPU 100 is basically meant for doing image processing, larger file processing. GPU P100 is very useful. You can go for GPU T4 into 2 slices. TPU also they are providing, but for my case, it's a normal decision tree, so I have not taken any accelerator for my case. But if you are going for image processing, speech processing task, you can always choose GPU, but there is a time limit. You can get 30 hours per week, not more than that. And you can also do your programming whether you have internet on or whether internet off, doesn't matter. You can, if you do not have much time to run the entire notebook, for example, image processing takes 12 hours or 14 hours. In that case, you can schedule the notebook, you trigger, set the frequency, okay, set the frequency and start date and end date. Okay, frequency is daily, weekly or monthly. The code will be automatically running on your background, even if your system is off, your browser is not working, and you are offline, but the code will run on server till the end. It may take 14 hours or 16 hours or 18 hours. The process will continue. You can do your own work. You can go to your office, complete your task, and then come back and see that the code is complete and ready. If there is no bug, and you can also get some code help here, and you can get some code help. Lot of sections are added. You can type something, they will show you how to connect to BigQuery, Google Cloud Storage, connect to AutoML. Lot of training is given over here, and then you can upload your own data set. You can save your version by clicking on this. Either you can go for quick save, that will take very less time, and if you want to save and run and commit it for all, then you can do it also. That option is given. And if you want to carry this file somewhere else, you can download the notebook from here, or if you have existing notebook, you can upload the notebook from here. You can create a Jupyter notebook over here. You can select language, Python or R, it's up to you. I prefer Python. Editor type you can choose. If you want to choose a notebook, or if you want to do some scripting, you can do it. You can add some collaborator over here if you feel that you have a team, and if you want to collaborate with somebody else who will be doing simultaneously with you on this platform, it is possible. And many other things. And here you can share your code with somebody else. You can make it public. I made it public. If you go through if you want to make it public so that people can see, they can see. And you can make it private as well. And I would like to show my page, which is quite interesting. You can sometime delve into it. We'll get a lot of insights. I have created a lot of code, including explainable AI, your deep learning, machine learning. You can see 30 notebooks are created over here. A lot of notebook is there, and also you will be getting some GenAI, LLM, because I'm associated with Liverpool John Moores University. I am there as an adjunct professor, so I do a lot of research over there. You can do open LLM work like Falcon 7B Instruct, open a Cox proportional model, the deep learning like attention mechanism, LSTM. I have created a lot of notebook over there. You can just check it out. We have also contributed a lot of data sets. 5 data sets we have contributed. You can check out this data set, and we have got a lot of bronze medal also over here. And if you look into the profile, my profile, you will be getting, just a moment, your work. So you can see that we have got 1,300. I have got 1,394 rank over 15,240 people over Kaggle existing, and I have got a lot of medals and badges over here. You can see the badges. This is competitor badge. This is research competitor. This is code submitter, Python coder, code uploader. So I request all of you to please get involved with this kind of platform where you get a lot of recognition, international recognitions, and they give you medal. I have got one medal, 3 medals as dataset expert, notebook contributor. I've got 1 medal. So it's a very good platform you can try out. So, and now I'm done. And if you have any question, you can ask me. Yeah, I'm open to questions, or else we will wind up the session if you are happy with it. Uh, I request moderator to please intervene. We will wind up the session.
Sir, actually, there's a question from one of the faculties of how to connect with you. So could you please answer that, sir?
I could not hear this question actually. I believe there is some problem. I was expecting some question, but I could not hear it.
Sir,
May I know?
actually, that question was in the chat box.
Okay. I have not seen it. I'm sorry. Okay. Can I share my number or my email? I'm sharing my email ID. You can connect with me. Okay, anytime. Yeah, I've given my email ID over there, so you can connect with me, and my number. I'm giving you my number as well. I'm very much open to doing collaborative research. If somebody is interested, I'm very thankful to them. I believe that you have enjoyed the session, and I'd like to thank you all for your patience. I believe that all are working in different institutions, and it's very difficult, and this time, because the examination is going on in almost all the colleges and universities, so it's very difficult to do such programs. I'm really thankful to the organizer, hosting this program and inviting me. I'm really grateful to Dr. Maithili from KG Reddy College for giving me this opportunity. Thank you so much. Is there any more question, or shall I leave?
I guess there are no more questions, sir, and thank you so much for joining us today.
Yeah.
It was very informative.
Thank you. Thank you so much.
On this note, the next session will be starting by 5 o'clock. Please rejoin by 5 o'clock. Thank you. Good evening, everyone. Welcome back to the session. So in the day 2 of the session, the last session is a lab session, which is going to be handled by Dr. C. Vanmati. Ma'am has already joined us yesterday for the Python tutorial. Today, she will be teaching Python for predictive analysis. Ma'am, handing over the session to you. Thank you.
Thank you, ma'am. So good evening, everyone. And the today's topic is developing AI models for predictive analysis. Already you have attending this AI for future for 2 days. So you might have got more insight about the AI models, various AI models available for predictive analysis. Let's start with the introduction of predictive analysis. So it is a technique which uses the data and statistical algorithms and machine learning to identify the future outcomes. So why this predictive analysis is very important in businesses? Like, it is used for taking the informed decisions, and it is widely used in the applications where we wanted to take the decisions based on the customer behavior or data which is existing, or with the past data, so we can make good decisions for the businesses using these predictions. So the applications like the customer behavior prediction and the fraud detection and risk assessment in the businesses are the predominantly used applications where the predictive analysis plays a major role. Apart from this, we are using the predictive analysis for medical applications and other fields like stock market prediction. In all the fields, we are using the predictive analysis, and AI is involved in most of the applications where it needs a decision. Simply with the help of the data which is existing, which is already available, so we are able to make a decisions in a good way and a better way by using the AI models. So there are a series of steps we'll be using for developing the AI models. First, defining the problem and objectives. Based on the objectives, we'll gather the data for the respective application. Then select the appropriate algorithm, train and validate the model, evaluate and fine tune the model, and deploy and monitor it. So let's see the steps in detail. So first step is define the problem and the objectives. So first, we should know about what the problem we are going to solve and what are the success metrics. Based on that, which criteria we are going to measure the particular application based on the prediction, that we need to be clear. So example, in the sales, if you take the forecasting of the sales might be important. That would be the output that we can get it from the prediction. So how much sales can be done in the future based on the past histories, that we can predict it by using the forecasting features which is available in the predictive models. And similarly, predicting the customer churn, like the customer attrition can be found or can be predicted approximately how many customers are not using it for past 10 years or past years based on the particular period of time. Over a period of time, what is the customer behavior, that can be analyzed by using the predictive models. So the next one is, once we analyze the objective and the target what we are going to predict, so based on that we can collect the data related to the objective. So that data can be from various sources, like it can be from historical records, or it might be from the sensors like IoT devices. It can be medical devices or anything. And it can be user generated data, like we are getting the data from the Twitter or from the movie reviews. So those type of live user data also be analyzed for making a business decision. And important thing in the preparing of the data is data pre-processing. So in the data pre-processing, will make the data proper before it is processed. Before we do the analysis, we'll check whether all the data which we are going to pass it to the model is in a proper way. So that is, we'll do it in the data pre-processing. So here it involves handling of missing values, finding the outliers and inconsistencies in the data that is found, and that is removed, and it is fine-tuned, and then it fed to the model. And the next one is the feature engineering, which is a technique we'll use for transferring data into our meaningful inputs. If any inputs is not good, and we feel that the particular column is not giving importance, or it is not placing a major role in your prediction, that can be removed from the data set, from the data, and then it will be fed to the model. And there are different data types in the classification model which we are going to take. There are various data types are available, or different types of inputs are will consider it, and will consider it, feed it for the various applications. So it can be a numerical data, or it can be a categorical data, or time series, maybe a image data, or text data, audio or video data. But regardless of the data type, the labels in the classification is always a categorical data. For example, in the numerical data applications, and the data type will be the numbers. Example, in the medical image analysis, or the medical data, we'll analyze the various features like cholesterol, age, BP. So that values will be in the numerical form, it will be in the numbers. So based on the number data which we have, the model predicts the medical conditions, whether it is a disease or non-disease data, that can be predicted. And similarly, in the categorical data, the data will be in the form of categories. So that can be with a single binary classification, or it can be a multi-classification where we have more than one decision variable. So like examples, in a email, if you want to detect whether it is a spam or not, so here we have two categories. Similarly, the customer satisfaction prediction features, like the responses from the various surveys, and the label can be a medium, low or high satisfaction. So the model can be built to categorize the various types of emails and predict the customer satisfaction levels in the customer database. And similarly, when you take the time series data application, like in the stock market prediction or forecasting of the weather, or comes under the time series data applications, where we'll have the historical stock prices and historical climatic conditions based on the temperature and weather, humidity, all these things. So based on the previous history, we'll be able to predict the model and the forecast what could be in the future. And in case of image data applications, the input values can be in the images, and that images are converted into a pixel values, and we can classify those image data, and we can predict the valuable insight from the data set. And similarly, text data applications, as I told, this can be a customer reviews, or any comments which we get through the Twitters and Facebook, other social media applications, that we can analyze it. And the labels can be a positive comment or negative comment or a neutral comment. So that kind of sentiment analysis can be done. Those applications comes under text data applications. And similarly, we have the applications related to audio and video, where audio applications we have for analyzing the audio recordings of the speech, and that can be converted into the audio features, and we can analyze what is that audio about, whether it is happy, sad, or angry. And based on these data, we can classify the various emotions which takes place in the audio or in the video frame. So these are the various types of data which we can handle it using the predictive analysis. And already we have gone through this various types of machine learning algorithms. So it is classified into supervised, unsupervised, and we have reinforcement learning, enforcement, ensemble learning. Other learning methods are available. Maybe you might have come across all these methods. So in the supervised learning, we have regression, linear regression, decision trees. In the classification, we have the SVM, logical regression, and in the unsupervised, we have clustering, and we have the dimensional reduction techniques like PCA and independent principal component analysis, and we have the linear discriminant analysis models we have. And similarly, in the deep learning models, we have neural network, LSTM or NLSTM, then model networks. Based on neural networks also we have. And in the ensemble learning is available for combining or taking the best model out of the various predictive models. So we have various technique we have that is not mentioned in this slide. Ensemble learning has like bagging, boosting, stacking. So various ensemble learning algorithms are there from which we can take out the best model which is suitable for our data. Okay. And that is the third step, choosing the model. So based on our input data and the application, we can choose the best model, or we can try with various models, and whichever model is giving the better results, we can take it out and we can consider it. And the fourth step in the predictive model is training and validating the model. So once the model is selected, so we have to train the model with the training data. So for that, we are splitting the data into training and testing. And once the model is trained, we'll do the validation. And in the validation, we are using hyperparameter tuning and k-fold validation methods for doing the validation. And these are the various platforms we are using it for developing, implementing our predictive models: TensorFlow, PyTorch, or Scikit-learn. Now we are going to use the Google Colab, so which is the online platform which provides the platform for using the AI models, developing the AI models. And the last one is evaluate and fine tune the model. So once your model is built and once we get the result, so we need to verify whether the results which we obtained is a correct one or not, or how much results we achieved, that we can validate it by using the matrices, so which is the state of art matrix, which is used to evaluate the model. So before going to this terms, so we'll see what is a confusion matrix. Okay, so in all the applications, whenever you run the AI models, definitely a confusion matrix will be there. So this is a matrix which is used for seeing the summary of the prediction results, because we are going to predict the model whether your model is predicting the data which is correctly or not. So that can be a positive prediction or it can be a negative prediction. So two types of predictions are are the outcomes of the prediction results. So that is broken down into a matrix called as a confusion matrix. So it helps to evaluate the performance of the classification model. So this is the structure of the matrix. So we have the true positive, false negative, false positive, and true negative. And true positive refers correctly predicted positive classes, and true negative refers correctly predicted negative classes, these two classes. And similarly, false negative and false positive are the actual positive cases incorrectly predicted as a negative, and false positive is actual negative classes are incorrectly predicted as a positive. So in case of model prediction, we need to take care of these two values, false negative and false positive, even though the accuracy of the application is very high, because it depends on the applications where we can give much importance and we can give the less importance according to these two parameters, false negative and false positive. In case of medical applications, if you take this, false negative and false positive should be very less, because this leads to a wrong treatment for a patient, or missing a person who is not treated because of this classification. That in cases this parameters are very much crucial in the applications where the importance is very much high. So based on this matrix, which is a 2x2 matrix, which can be extended for the number of parameters. So it is based on the classification, whether it is correctly predicting or not. So these 4 terms we are using for representation, and based on this we have the various matrices we are using for evaluating the model. First one is the accuracy. So accuracy formula is true positive plus true negative, and these formulas you refer it later. This accuracy refers the proportion of the correctly predicted classes. Similarly, we have a precision, so which is used for predicting the positives are actually positive, and we have the other two terms, sensitivity and specificity, which is a recall, and the specificity is proportion of the actual negatives are correctly predicted. And we have the F1 score. F1 score is a harmonic mean of the precision and recall, balancing the both. So F1 score equal to 2 into precision multiplied by recall divided by precision plus recall. So these are the various matrices. We'll be using it for measuring our model is correctly predicting the values or not. And apart from that, we are using two terms for representing the error rates in the model, error rates produced by the model. See, we are using type 1 error and type 2 error. Type 1 error is error occurs when the model predicts the positive instant, but it is actually negative. So in this column, so here it represents the type 1 error, and the false negative represents the type 2 error. And formulas given here for measuring the type 1 and type 2 errors. Later we refer it, and this is an example for a confusion matrix source I have taken from jigs for jigs. So these are the examples where we have the actual values of the data set with the 10 samples. In the image recognition, a dog is recognized as an image and not dog is how it is predicting the images. So here in the predicted values, a dog is recognized as a dog, so it is a true positive. Similarly, dog is predicted as a not dog. Here it is a false negative. Similarly, dog is true positive, and here not dog is true negative. Similarly, other values are mapped with the true positive and false negative. So here, by seeing the confusion matrix, if 10 samples are there, we can easily analyze how many samples are considered for the model, and how the true positive and true negative and false positive and false negative values are classified. So the count should be equal to the number of data set, that is number of records. So likewise, in the confusion matrix, by seeing the confusion matrix, one can analyze how well the model predicts the outputs can be visually seen. So it is commonly used in the binary classification problems, and it is also used in the multi-classification problems. So the performance evaluation models like in spam filtering, fraud detection, medical diagnosis. So confusion matrix is widely used. And the advantages, it provides a detailed performance for each and every metric what is chosen. So supports various performance metrics calculation like sensitivity, specificity, F1 score, and recall. All these measures can be calculated by using the confusion matrix calculation. And in case of multi-class classification, we'll be looking for multi decisions. So in that case, the confusion matrix may not be efficient. So it leads, if the data set is imbalanced, if the data set is not correct, then it leads to the wrong decisions. So always, whenever we do the predictive analysis, our data set should be balanced, and the data which we are going to train the model should be a correct one. And the last one is deploying and monitoring the model. This I'll do later. And the sorry. So the next topic which we are going to see is the pandas. So you might have come across the word in the Python programming. You must be seeing the import pandas word and the import numpy word. So these are the Python libraries which will be using it for data manipulation and numerical analysis. Okay. So pandas is a powerful Python library for data manipulation and analysis. So it provides easy to use data structures and functions needed to work with structured data efficiently. So as we are going to take the input to the model as in the form of a CSV file, the Excel file. So it is a structured data which is arranged in the rows and column wise. So in order to handle the structured data, so Python provides a library called as pandas. So it has various functions to effectively handle the pre-processing and other manipulations can be efficiently handled by using these libraries. Okay, so the pandas can clean the messy data sets and make them readable and the relevant. So for mainly it is highly used for cleaning the data, and we can use some advanced function like correlation and plotting of the graph that is also available in the pandas. So it is very much important in the data science to identify or to analyze the data before it is processed. So for that, Python provides a powerful library called as pandas. See what are the features are available in the pandas and what are the functions are there in the pandas and how to use it. Okay. So installing the pandas, since it is a library, we need to install it if it is required to use it in your Python. So for installing, we'll use pip install pandas. So this will install the pandas library into your Python environment. And after installing, if you want to use this as inside the Python program, we are using import pandas as PD. So which is the object is created with the pandas library, and later we'll use this PD instance for creating the objects. So yesterday I have taken the representation, like this is used for creating the list values. So since we are dealing with the Excel data, that Excel is considered as a data frame and it is considered as a matrix in the pandas. So a single one-dimensional array in the pandas is referred as a series. So A is a list, contains some values. So I can create a pandas data frame variable as a single dimensional array, which is how to create is pd dot. This is a function name for creating the pandas series variable. So pd dot series of A, it creates the matrix of values with a single column as a one-dimensional array, and the data type is a int type. Similarly, you can create the customized indexes. Customized indexes for the labels which we have it in the existing array. So that can be done by using the index, mentioning the index equal to the customized column names which we wanted to have. By default it is 0, 1, 2. By using this index values, you can fetch the values of the panda series. The same you can do with by changing the index name, so that the index of 1 is changed to x, and index of 7 is changed to y, and 2 to z. Likewise, you can change the index of the existing series by using the index function. Sorry. And the next one is creating the data frame. So data frame is similar to the multi-dimensional matrix. So series is like a column, and we can create a matrix form of data by using the pandas. So here we are using the keyword called as data frame, so that your data will be arranged in the rows and columns in matrix format. You can directly take the Excel data, and you can consider and you can change it to the data frame by using the pandas PD. That's why I'm taking this pandas library and numpy library. So this is my data, which is given in the list form along with the dictionary. It is given since we have the labeled values of the data in the Excel with the various values. So it is dictionary kind of data with the nested list. So here I am converting this pandas. By using the pandas, I'm converting the dictionary list values into the data frame using this data frame function, so that the output looks, it is converted into rows and values with the label as a dictionary keys, calories and duration, and the respective values are placed in the column. So which is similar to your data table. And here if I want to fetch the values like how we fetch it in the list, you can mention the index location of it, and if you want to retrieve the particular value from the column, we will use the two-dimensional representation mentioning the rows and column values, so that the particular element will get retrieved. And same here, if I wanted to change the default index values to customized variables for indexing, so you can use the index so that the default values of the data frame indexing will be changed to the customized variable names. So here it is named as day 1, day 2, day 3. So the default values 0, 1, 2 is changed to day 1, day 2, day 3. And this is a function used to read the CSV file into the data frame. Okay. So the function name is pd dot pandas variable pd dot read CSV, the input data which you are going to input. It will be in the CSV format, so data.csv. So it will be saved into the data frame variable. So it's a user defined variable. So df, so I have the data in data.csv. So once it is read, so this is my data, so which is having the comma separated file, that is CSV file, so which is having 4 fields, 4 columns, or it is attributes: duration, pulse, max pulse, calories with the respective values, and number of rows is given. So once I read this by using read CSV file and input values given, so it is fetching the values from the CSV file, and the data frame is created, and it is holding the values of the CSV file. And once it is stored into data frame, and you can do the manipulation which is the library provides according to your requirement. And this is a function which is used to fetch the number of maximum rows from the data frame which we considered. So here, so if we use pd.options.display.max rows, which fetches the maximum number of rows from the PD which is loaded. And we have other options in the data frames for viewing the first few rows and last few rows. By default, if I use pd.head, which is going to read the top 5 rows from the data frame, and if we use the tail, this is going to fetch the specified number of rows from the bottom. So by default, it is fetching the 5 records, and if we mentioned how many records you wanted to fetch, we need to mention it in the inside the bracket, so that the respective number of rows can be fetched from the data frame. And we have the other function called as info function, so which is going to give the information about the data set, how many records are there and what is the data about. So that we'll see in detail when we see the it in the program. And the next one is data cleaning. As I already told, the first phase of the predictive analysis will be the data cleaning. So cleaning involves removing the bad data from the data set. So it can be removing the empty cells or cleaning the data which is in the wrong format, like in the date format. If we consider, if any date format is not correct in any of the columns, so that formats you can correct it, or you can change the values which is having floating point, and if you want only integers, that can be corrected. And you can clean the wrong data if you know the significance of the particular column, that can be done, and removing of the duplicates. So all these types of data cleaning is possible with the help of the pandas, with the help of the functions provided by the pandas library. We can simply do it by using the functions. And this example 2.csv file, like I'll show you example for this. So this is an example data set. Here we have 4 columns: duration, date, pulse, max pulse, and calories. So when you see the value here, the duration is given as of 0 to 16 minutes. So here the value is wrong here, so 450. So only if you know the data values, and if you feel that which is wrong data for the particular data set, you can clean it and you can remove the unwanted data by mentioning it in the functions, so that you can provide the correct data. And similarly, when you see here, you can see the date format which is not correct. So like that, wherever is format is missing or any empty values are there, we can remove it and we can provide the clean data to the model, so that the model will do the correct predictions. So these type of cleaning we can do it before it is fed to the model. So removing the empty cells by using the pandas library is done by using the df.drop.na function. So this is for removing the null values from the data set. So automatically if we apply this df.drop.na, because df is a data frame which already we have saved our Excel file into this data frame. Now if I use this function drop.na, this is going to remove the null values from the data frame. And if you wanted to change the actual values of the data frame itself, then you can use in place equal to true argument, so that the actual variable name, the changes will happen and the updated values will be saved in the df. Or else you can have the another variable name so that the updated values will be saved into another data frame. And next one is cleaning the wrong data is possible by using the location, because you wanted to know which cells you wanted to clean and which format you wanted to change. Once it is available as a data frame, you can treat every column as a individual list values, and you can apply the normal list operations, whatever the formatting you wanted to do. That can be done by using the list functions. Using the location, this function is used to index or fetch the location of the particular cells from the data frame. And remove the duplicate values are done by using the duplicated function. So name of the data frame dot duplicated, simply it removes the duplicate from the data frame, and the result you can save it into another variable. And the same is given here. So this is for missing data, which is removing null values, and duplicates are removed by using the duplicates. And you can use the normal functions, list functions, for changing data type into float. So if you want to have only the integer data type and you wanted to change it to float type, the respective operations can be done by using the changing the data types, so that whatever data type you need, that can be converted into the respective data types in the columns. And another important feature in the pandas is the data correlation, so which is used for correlating the various attributes, how the relationship exists between the attributes, that can be measured by using the correlation function. So it calculates the relationship between each column in your data, so that how much important or how the changes in the values of one attributes affects the values of the other attributes can be predicted by using this correlation matrix. So the matrix values varies from -1 to 1. So the least value means it is having less correlation, and 1 means a perfect correlation. So in the previous data set, how the values were correlated with each other is given here. Anyway, the direct correlation, because each attribute is always 1, because it is means the same attribute itself. So the correlation for duration is 1. We can say it as a perfect correlation. but the values with other attributes like pulse with duration or pulse with max pulse or pulse with calories, if this is having the highest correlation, which means the increase in the pulse, it increases the max pulse. Similarly, max pulse, maximum pulse rate increase or decreases the calories. So like that, you can have the meaningful insight about the attributes with the other attributes. We can see it by using the correlation matrix. So by using this matrix, you can analyze the data set, which columns you cannot remove or which columns is having higher importance in the data set. That can be predicted by using the correlation matrix. And we have the metrics for good correlation, perfect correlation, and bad correlation based on the values which is having. So if we have lesser values like nearby -1, which is bad correlation, and nearby +1 is called as a good correlation. And then we are using the data split for feeding the data for training the model as well as for testing the model. So usually the split happens for 80-20 will have it, or 70-30 will have it. When we train the model, usually we have to maintain the ratio of this 80-20 or 70-20, because otherwise your model will be overfit or underfit. So in order to do that splitting of the data set, it is there in the data frame. So you can split the ratio of 75%. The remaining data will be assigned to the testing. And here, one of the challenge while splitting the rows is training as well as data. This functionality can be achieved by using the sample, because the splitting of the data should be in a normal way, like when we apply the k-fold methods are available for random splitting of the data. So whenever the model is trained, randomly it picks the data from the data frame, that's 75% and 25%, and the model will be trained. So that can be achieved by using the sample fraction equal to 1. So if you use this keyword fraction equal to 1, your data will be randomly shuffled, and every time you are feeding the right data to the model. And we are using various development environments for model development. We are using the TensorFlow, or you can use the Keras or scikit-learn. And now the Keras is joined with the TensorFlow. These libraries are combined, and you can go for using the TensorFlow for running the deep learning models, especially for building and training the neural network model. We can use efficiently with the TensorFlow. And for simple applications with lesser number of data sizes, if the size of data size is very less, we can go for using the scikit-learn, which gives the better results for running the machine learning algorithms such as support vector machine and random forest and k-means. We'll see it later. And we have the other library called as NumPy. So this is the library. We will use it for doing the numerical operations. So particularly for having the matrix operations, we'll use this Python library NumPy. Here everything is treated as array. Anyway, the data set also we are considering it as in a Excel form, in the CSV form, that is treated as a input is treated as in the matrix form. So that matrix operations only we are going to deal with the NumPy library. So it is a multidimensional arrays. So it provides efficient and convenient way of doing the array manipulation for large data set. And it provides the wide range of mathematical functions for array operations and computations. So it enables operations or arrays with different shapes and sizes. So this we cannot do it with the normal library functions. So even with the large size of matrices with 100 or more than 100 size also, it is the operation results are quickly done by using this NumPy library. Because of this running time, this libraries become familiar and we are using it in many applications. And installing this NumPy is using the pip install NumPy, and similarly importing NumPy inside the code is import NumPy as NP. So like similarly import pandas as PD, here object as NP. So any variable name you can use. It need not be NP or PD. Any name we can use. And let's see some built-in functions which is available in the NumPy. We have functions like which is going to create the array. So name of the NumPy NP dot array of list values. This is going to create an array with 2 rows with 3 columns. Similarly, if we want to create eigenvalues, we are using the function called as I of 3, and similarly zeros with the 2, 3 if we give, and 2 rows with 3 columns are created with the matrix with the zeros, and NP a range of 0, a range of 0, 10, 2. It is going to create an array with starting value as 0 and the increment value as 2 and ending value as n minus 1. And similarly, ones is going to create number of ones with these byte size, and we are using the random.randint. So most of the cases, if you want to generate the column by using the random numbers or with the specified numbers range, in that cases we will use the randint function. So it is widely used in the data set adjustment. If some columns are missing and if you wanted to generate it randomly, in that cases you can go for using this function and can create a specific column so that a new column can be created with your required range of values. This is random.randint of 0, 10, 3, 3. The third parameter specifies the size of, and 0, 10 specifies the random number between 0 to 10 will get generated. And these are the examples. So we need to import this function, import the library, and in order to use the functions inside the NumPy. So zeros, ones, a range are the various functions and the outputs are given here. And various array operations you can do it very easily by using the NumPy, like addition, subtraction, multiplication, division. So these features are not available in any of the programming languages. Simply whatever may be the size of the array, we can do, but restrict to the mathematical rules. The size of the array should be equal, and the number of columns and rows should be those constraints need to be satisfied when we do the array operations. Other than that, you can very well use the operations, array operations, which is supported in the NumPy. And this is going to give how to retrieve the array values. So once we have it in the list type of data, then we can use it by using the slicing operator 1:4. It is going to fetch the list value with starting with index 1, and it is going to fetch the value with n-1. So up to third index it is going to fetch. So it is fetching the values 2, 3, 4. Similarly, we have the functions related to shape and dimensions. Once you have the size of the array with some size, and if you wanted to know what is the size of the data, that can be fetched by using the array shape. And you wanted to know the what is the dimension of the data, that information about the particular matrix, like if you have the data frame with CSV file, after importing you wanted to know what is the size and what is the dimension of that can be fetched once it is converted into an array, and the details you can fetch it by using these functions. And similarly, we have option called as reshape, so that you can change the shape and the size of the array by adding the additional columns or additional rows. That is possible by using the reshaping of the array values. And similarly, NumPy provides other functions like sin, cos, other mathematical functions is also supported in the NumPy. So simply you can use those functions for calculating the respective array values. You need not to loop through an array. Simply you can calculate pass the array values, and you can get the respective complete record sine values and cosine values. You can get it. And similarly, it provides the various mathematical features like statistical features. We can analyze it from the data set: mean, median, variance, standard deviation. So those kind of statistical features about the particular data set can be calculated by using this, and this is used for analyzing the range of the data which we have in the particular attribute. That can be easily analyzed by using or by seeing the statistical features about the attributes. And we have the important module called as random module in the NumPy, and this is for creating the random integers. And if you want to create the integers with floating point values, then you can go for generating the uniform random numbers. Or if you want to do it for integer values, then you can use it for generated by using the integers. So here the random integer range of 3 cross 3, 3 has given. So it is generating the random array of 3 cross 3 matrix. Here the third output. And similarly here if I give uniform values of 0, 1 is given, so it is going to generate any one random number, and here it is a random floating point number. So NumPy is widely used in the machine learning for various applications. Sorry. Okay, it is widely used in the applications of the machine learning. Machine learning applications widely used. So here it provides efficient array operations, support for multidimensional arrays, and it provides broadcasting of the values you can change with any size. And you can use this, and you can pass this array values with other functions And here we have the random number generation features for generating the synthesized data into the existing data set, or you can create your own data set with the random number generation. And by using the NumPy, it provides the it handles the memory efficiently, and the data pre-processing features are very good in the NumPy. And similarly, the optimization, the performance in terms of performance is high, and it is very much compatible with the pandas library. So these two libraries, we are using it in the most of the predictive analysis for reading the data set and for handling the data.
यार इसकी लाइन थोड़ी कम लगती है मुझे पापा को नहीं ये सही है जेडीएम क्वालिटी ये
We'll take 5 minutes break. We'll continue at 6:05. We shall continue. So those two libraries like pandas and numpy are used in the machine learning for doing the data manipulation and also to do this various operation. The next library will see it as Seaborn. So we have two libraries called as Seaborn and Matplotlib. So those two are used for creating the simplified form of charts with more details with attractive visualization. We can get it by using those two libraries. So this is an example of Seaborn libraries chart. So import Seaborn as the object name SNS and import matplot library pyplot as a plot. So it has various types of plots, like how we'll do it exactly with the Excel in a better way. This libraries provides the attractive, colorful details about the data which we have, and directly we can use the variable names what we can have it for x axis and y axis, and what type of plot you wanted to use it. So we have the set of attributes are available for decorating the chart according to a requirement, according to a style what we want. So we can give the attributes, respective attribute we can use it when we use the functions. So this is an example for line plot. Similarly, we have the a plot with categorical data with values, x-axis values and y-axis values. So you can give the labels and what input you wanted to pass for the data. You can graph. You can give here, and it is going to give the data values with the input, graph with the input which is applied. And similarly here you can apply the various functions on the data along with the mathematical operations. You can apply it on the data, and that can be shown by using the various plots. That is also possible in the Python. And here we have the heat maps for visualizing the relationship between the matrix of the data, which is a correlation matrix. So which represents what correlation, how correlation is, how much correlation is there in between the various attributes is given, and with the scale value of least correlation to highest correlation is given. So it is represented with different colors, so that by seeing this maps or by seeing these images, so one can easily understand how much correlation exists between the variables, are analyzed very easily by using this graphs. Similarly, we have the other called as matplot library. So similar to the Seaborn, here also we can create attractive charts and the graphs by supplying the values. So you can refer the syntax later with the respective charts, how you can fetch the values and how you can pass the parameters as the data frame or a series of the pandas variable that you can pass it. You can use the variable name instead of this values, because you wanted to give the data about the various attributes which is present, and whatever attributes you are interested here, that you can mention it here, and the same can be plotted here. And we have other graph called as histogram values, which is used for displaying the spread across the data can be displayed by using the histogram graph. And similarly, we have the pie chart, line chart, subplots also available, because in a single graph, two graphs you can plot it based on your requirements. Like this, we have the additional libraries for doing the data analysis, and you can have the attractive charts as a result of your predictive analysis. And now see the analysis and the exploratory analysis which we'll do for predictive analysis. We'll take the example of sleep prediction. Here this data set has various attributes like person ID, gender, age, occupation, sleep duration, quality of the sleep, physical activity level, stress level, BMI category, blood pressure, heart rate, and sleep disorder. So based on this analysis, based on the data provided, we can analyze the data by using the various plots and various data manipulation techniques which is available in the pandas can be achieved. For that, we are using the necessary libraries. And so since my data set is inside the drive, so I given the drive mount so that your drive files will be ready for in the Python for reading. And here, once the file path is specified, you can read the CSV file by using pd.read_CSV file, as we discussed in the pandas. Your entire CSV file are stored as a pandas variable as a data frame. Now your data, your CSV file is treated as a data frame, and whatever the operations you wanted to do with the data frames or functions is available in the data frames that could be used for doing the exploration about the data. And really here we have the outputs. So this is about df.info. As I already told, this df.info gives the information about the data set which is loaded. So it gives what are the columns available and how many not null values. Null values, since my data is clear, so it is giving the correct values. And the data types of the respective values also given, float, integer, and the objects. And this is by using the plot matplot library. I have plotted this graph, histogram plot of the sleep duration versus the number of hours is given here. And so you can do some useful insight extraction of the extraction of the data analysis. Everything you can do it by doing the exploratory analysis. So exploratory analysis is used for understanding the structure and patterns like characteristics of the data set before it is applying to the machine learning algorithms. So this is used for removing the anomalies or identifying the trends. A relationship within the data can be analyzed, so before it is processed. That is possible by using the exploratory analysis. By using the various plots, you can analyze the data and you can relate the data with attributes directly affects the other attributes that you can check it by using the various plots, choosing the attributes. So here's sleep disorder, how it affects gives the stress level is plotted here. And similarly, prevalence of sleep disorders across the age group is plotted here. Already we have the age group, and you can analyze the data which is present, and you can write the exploratory data analysis by using this various graphs that can be done by using the Seaborn and the Matplot libraries. And next we'll see example with the decision classifier for making the predictive modeling. So here the same disease analysis will consider. So in this example, the attributes which we are going to consider as are we are going to take it as age, BMI, blood pressure, glucose, cholesterol, disease. In this example, the data set is not in the CSV file. It is possible to generate the data set with the help of Python code. That is only done here. So age is automatically generated, starting value is 20 and the ending value is 70. That is within this range it will be generated with integer values, and number of records I want to generate is 100. Similarly, BMI values I want to make it as in the points that what in the range given as starting range and ending range. So within this range, random numbers will get generated and it will be added in the BMI attribute. Similarly, it is generated with random values. So these type of generating the values are called as a synthetic dataset generation. So if any one values are not present in the column, any attribute values you wanted to generate, but the dataset doesn't have that field, you can generate your own values for the respective values randomly, and your dataset can hold that attribute. So that can be done by using the random int function or random uniform function. According to your requirement, you can generate. And similarly, this seed function, it takes care of and ensures the reproducibility of the results of the data set is in the correct form. That can be taken care by the seed function every time the rand function runs. So once the data set is created, a data frame is created by using the pandas. Then as usual, you can have the data set split. This maybe the predictive analysis steps covered in the previous session. So the values splitting of the data set, what is your features which you are going to consider, and what is your target variable. The target variable is you wanted to identify whether the disease is present or not, so that you are considering it as a y variable, and other variables you are keeping it as a x-axis. And then the third step is training and testing data split. You are splitting the data set and keeping it for training as well as for testing is provided here, and test size is 0.2 and random status equal to 42. After that, once the training data set is ready, then you can feed this trained data split into the model. So the model which here used is decision pre-classifier and model fit of the values which we are passing, the training and values we are passing here. And then once the model is trained, then you can use the model for testing. So the testing data is passed here to predict the model accuracy. So it is tested with the predicted model, and for measuring the various matrices, here confusion matrix is plotted and accuracy and classification report is given. So and also here we are displaying the statistical features, and about the data set is described here, and each and every data set information is given here along with the accuracy, confusion matrix and report. So you can see the results here. It is having the input data as this is my input data. So first I have given print of my data frame, so it is get printed, and then I told to display the statistical features by using the information function. So it is giving the statistical features, what is the count and what is the median, what is the standard deviation, minimum value, maximum value. And then this 25, 50, 75 gives the upper values and lower values within this 25% of data and 50% of data and 75% of data is given for the all the attributes. And similarly, it gives the detail about the data, whether the description about the data, not null values will be listed here, and the memory usage and the accuracy percentage for this data is given here. So the classification report says the precision values, recall values, since our data set is not the original data set, it is generated by the system with random values. So we will not have the correct accuracy values with the highest value of the data set. How we'll get it for the other data set? We cannot expect this. Since the data set generation is a random, so we are getting very lesser values of the accuracy and lesser value of the precision, recall and F1 score. And the results are shown for the predicted diseases with various values are given here. So like this, you can do the exploratory analysis by using the pandas and NumPy libraries. You can generate your own data set, and model prediction, model comparison and all, just you can call the model, and whatever the training and testing data you wanted to fit, you can fit here and you can get the results from the model. And next example, we'll see it for crop prediction analysis. So crop prediction analysis, same, the data set has various values with the parameters which we consider for better crop yield prediction is nitrogen, phosphorus and potassium, and the temperature level and the humidity of the soil, pH level of the soil, and rainfall prediction in the particular area. And the labels gives the various vegetables and fruits values, and it is having the record of 2200 rows. So these are the various attributes available. So in this example, it is tried with various machine learning algorithms and importing libraries with various plots. So here it uses the multi-class classification with various labels, various attributes for rice and various flour, wheat, like multiple decisions as are right with the help of the multi-class classification. So here exploratory data analysis is main thing to analyze the data. So here the same crop info, crop is a Panda data frame. So from where the values are retrieved. So it gives the information about the database, and describe will give the entire data description about the statistical features about the data set is given here. And whatever the values you wanted to consider, and if you want to take only unique values of the labels, that can be done by using the unique function which is available in the data frame. And we can count the label values, how much is there for each record can be counted. And heat map gives the correlation between the values with the selected features. And here we have the plot for the temperature of the data set which is chosen for the crop prediction, and here it shows the pH values. And here pair plot gives the hue values, how the data is scattered among the data set, can be fetched for all the variables, for all the labels is presented here. So whichever labels you are having interest, that labels alone you can fetch it and you can analyze it by using these graphs. So plenty of designs are available for plotting using the seaborne libraries. Later you can refer those libraries for your research purpose. And these are the box plot. You can do the analysis. And here the correlation already I told, correlation between the variables you can analyze by choosing the correlation variable features, like how many features you wanted to consider, that will be given here. So here the features which are selected as up to 7 features we are chosen here. So for those features it is given here. And similarly here it gives the summary about the data in the from the database. Head is going to retrieve first 5 records, and similarly tail is going to get last 5 records. And here the graph with is not, and in case of feature selection, the dominant features which you feel that will affect the crop yield alone is selected for the feature selection. Other features are left out here, so that you can do it, or by using the automated methods also you can do the feature selection. Then this classifier algorithms are applied to the model, and the accuracy of those models is measured here. So the first model is k-neighbor classifier is applied here, and the accuracy is given here for the various classification of the attributes, and their accuracy is given. And cross validation score, actually this validation score will test it with different splits of the database, so that we can test how well the model performance for the various split. That can be done with the k-fold validation. And the cross validation is done with the testing data, with the training data, how well it is performing in the testing and how well it is performing in the training. That is measured by using that. And here the model applied here is KNN, and the KNN accuracy is given here. And this is the confusion matrix of this KNN. And when you see the confusion matrix or accuracies, different model gives the different accuracy values, more or less, which is nearby the actual values, 97, 96 it is giving. So best model you can choose out of this, and you can apply the hyperparameter tuning in the KNN for doing the parameter tuning, so that you can analyze the various variables. You can change the accuracy. You can fine tune the accuracy by using the hyperparameter tuning. And here we have the decision tree classifier, then the confusion matrix and random forest. So this example is applied with all the machine learning models for comparison. Later you refer this code for checking the accuracy. So when you compare the other models, the naive-based classifier gives the better results of 99 compared to the other ones 96 and 97. So the confusion matrix also given here, and the extreme boost this is similar to your ensemble model. So it combines the all model results and it picks the best model from the existing one. So the model accuracy of this is given as XG boost is more or less near to the naive bias. So this may vary for the various a data set. According to the data set only the model performance may come. So we cannot assure that this model will best fit for the applications. We cannot assure it. So according to our requirements, according to the applications, we can choose the model and we can predict the output. This is another example, and the next example is predicting the consumer buying behavior. So this can be used for predicting the user behaviors when they buy the items. So this is a real-time sale data from the data set. It is having the customer buying habits, so much is brought in a particular region and through which channel it is brought. Either it can be an online or in person, that is mentioned by the channel, and the region wise data is given, the region code is given with the various attributes. So these attribute data analysis, they will do it by using the various exploratory analysis, and the prediction and forecasting also is possible for the existing historical data, so that they can predict the future prices and what is the customer behavior in the future, so that they can make the important business decisions based on the model predictions. So here based on the existing data, they can visualize the customer segment region wise, how much sales is happening, like what are the channels are best suitable for business strategy. Everything can be analyzed, and various combinations of the attributes we can list it out, and we can plot it by seeing the graphs. We can analyze, and the correlation matrix also be used for analyzing the various data which is present, the relations we can understand. So by using this, the important decisions can be made. This example shows how they are applying the principal component analysis. So in some situations, we have to consider the importance of the attributes which is present in the data set, where it is having or plays a major role in the entire process. So that can be identified, and that we can apply it by using the principal component analysis prediction, and that we can apply it after the exploratory analysis. I think so with this example I'll conclude the session. So predictive analysis you can do with the various machine learning models and deep learning models. So it is applied in the various applications like healthcare, finance, retail, and manufacturing. And the various challenges in the predictive analysis is data quality issues will be there, and model overfitting, underfitting. It is because of the generalization of unseen data, and data quality issues will get it because of incomplete and inconsistent data, because the data set plays an important role in the predictive analysis, because it the model reacts for the data. So once we have the correct data, only the model predicts it correctly. So the scalability issues are there for handling the large data set. Now it is slowly we are finding out the best models for handling the scalability issues. And when we do the predictive analysis, the model should not be biased for unfair predictions, that we need to take care. And The conclusion: predictive analysis transforms the data into actionable insight. Success depends on the data quality. Appropriate algorithms need to be chosen, and continuous monitoring should be there for analyzing the data and for developing the models. Thank you. Any questions? Okay, thank you.
Thank you so much, ma'am, for joining today. And also thank you so much to all the faculty.
So thank you everyone for your patient listening.
Thank you so much everyone for joining today. Tomorrow at 9:30 a.m. we'll have the sessions again. And the feedback form link is in the chat box. Please do fill up. Thank you so much for joining.